Hey, Jordan? 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 Jordan?
Hey, John.
Hey,
How's it going?
you ready?
Oh, my God. It's today?
It's today.
I forgot. Oh, my God. Lights, camera. Somebody get a makeup person.
We're ready. Relax.
I'm just kidding. I could see them all there.
You'll get used to this guy.
I'd like to welcome you to Examkrackers Test Reviews with Jordan and John. I'm Jordan.
And I'm John.
One of the things I'm going to encourage you to do as you go through these test questions with us is to go through every single problem on the test you did recently. On the problems that you got right, there's going to be a tendency on your part probably to skip over those problems. Don't do it. Why? Because even on those problems, John and I are going to impart MCAT wisdom, and we don't want you skipping those problems because you might miss that wisdom. Would you agree?
I agree. Don't skip problems. Go with us on every problem.
Excellent. You ready to get started?
I'm ready.
All right. Oh, hey, welcome back. We're looking at AAMC's Test 5R Passage 1 in the Physical Science section. And I gotta tell you, John, I'm already feeling intimidated.
Well, let me take this passage for you, Jordan.
All right.
All right. Let's just jump right in with question 1. Is reaction 1 exothermic under standard conditions? Very basic, simple question. They're asking, do you understand what exothermicity is? Exothermic means negative delta H. Take a look at reaction 1. Delta H is negative, so yes, it's exothermic. So we narrow it down to answer choices A and B. Answer A, yes, because heat must be added to initiate the reaction. Is that true of an exothermic reaction, Jordan? You have to add heat to initiate it?
No, in fact, that'd be the opposite.
Yeah, we get heat out of a reaction. So A is wrong. Leaves us only B. I hope the explanation is correct. Yes, because the standard enthalpy change is negative. That's correct. That's the definition of the exothermic reaction. Let's go to number 2, question number 2. Which of the following graphs best shows the effect of pressure on the equilibrium percentage yield of NH3 gas at 200 degrees Celsius? For this one, we're going to want to take a look at the table. And here we have our table. At 200 degrees Celsius, notice at 1 atmosphere, it's 15.3. At 100 atmospheres, we go up to 80. This is a jump of about 65. And then at 200 atmospheres, we only jump about 5. So what we're going to get is a leveling off in the graph. So let's see if we've got that in our graphs. And here we go. We've got the steep initial climb and then the leveling off. Answer choice C. All right, let's go to question number 3. The most likely role of the iron catalyst mixture used in reaction 1 is to, let's look at our answer choices.
We just said it. It's the iron catalyst in the mixture, so it's got to be something that a catalyst is going to do, meaning increase the rate of reaction.
Correct. The catalyst increases the rate of reaction by lowering the energy of activation. Choice number A, increase the rate of reaction. Number 4. If excess ammonia reacts with H2SO4 aqueous, which of the following compounds can be produced? Let's take a look. We've got ammonia, NH3, and then we have H2SO4. We want to know something about how these compounds react for the MCAT. NH3 is?
Base.
A base, a weak base. H2SO4, a strong acid. The definition of an acid is it donates a proton. Base accepts a proton. When this accepts a proton, we get NH4 plus. When this donates, we get HSO4 minus. Now we look and we say, okay, so that could work. NH4, HSO4. Looks a little funny. Let's look for that answer choice. Not there. So what's happening here? What's happening is HSO4 minus is still an acid. It can still donate a proton. So it donates another proton. Can it donate a proton to NH4 plus?
Not likely.
No, because NH4 plus is an acid, and we still have ammonia in the solution. So it's going to donate a proton to this ammonia, and we end up with a second NH4 plus. So we're going to have 2 NH4 pluses, and we're going to be left over with an SO4 2 minus. And those two come together, and that's answer choice D. Let's go to question 5. What kind of interactions take place between molecules of the product of reaction 1? So we take a look at reaction 1. Let me take a look at reaction 1. Okay, reaction 1 is back with our catalyst. Jordan, could you hold that for me?
Love to.
Thanks, sir. All right. What kind of interactions take place between the molecules of the products of reaction 1? Take a look at the products. What are the products? Ammonia. So all we have are ammonia. Now, we know that we could have hydrogen bonding. So answer choice B is possible and A is out, right? You should know that ammonia hydrogen bonds. What are the 3 atoms we need for a hydrogen bond?
F-O-N.
A fluoride, a nitrogen, or an oxygen for a hydrogen bond. Here we've got the nitrogen with the hydrogen. So we know hydrogen bonds are there. Now, what's our other choices? So our only possibles are B or D. Choice D, both hydrogen bonding and dipole-dipole. Is dipole-dipole a possibility here?
I suppose so, because a hydrogen bond really is a dipole-dipole, so.
That's true as well. And not only will you have hydrogen bonding, you're going to have dipole-dipole, which is caused when one of the molecules, or actually both molecules, have a dipole moment. And ammonia, of course, has a dipole moment. Let's go to question number 6. Which of the following ions involved in reaction 2 is the strongest base?
You still want that?
No, I think we can put this back.
Ditch it.
All right, let's take a look. In reaction 2, which is the strongest base? Well, the first thing I'm going to do before I go look at reaction 2, I'm actually going to look at the answer choices that they give me and see if I can get rid of anything. What would you get rid of right away? Jordan?
The proton at the bottom, D.
Yeah, that's an acid. D is out. Okay, anything else?
The Mg2 plus, probably not a good answer.
Mg2 plus is neutral, right, and you probably should know that for the MCAT. It's not really acidic or basic. At best, closest it could be would be an acid, but it's not. All right, because sometimes metal cations can be Lewis acids.
Okay.
So we're down to A or B. Now we know choice B, OH minus, is a strong base. In fact, what you should know actually is that the Kb for OH minus is 1. In other words, this is the measuring point for other bases. If you have a Kb higher than 1, you're a strong base. Lower than 1, you're a weak base. So the Kb of OH minus is 1. Now what about N3 minus? N3 minus, this is one of those things you look at on the MCAT and you say, what is that? I haven't used that. So what you want to do is try and create something that you have seen before. We take a look at this N3 minus. Let's make ammonia out of N3 minus. If we add protons to that, we make ammonia. Right? Now to get from ammonia to N3 minus, we subtract a proton, and when we do, we have NH2 minus. We subtract another proton, and we're going to get NH2 minus, and we subtract yet another one, and we get N3 minus. So basically, we have this series here. NH3, we already said, was what?
A base.
NH3 is a base. And does a base give up a proton?
No, it's going to suck up protons.
Yeah, exactly. A base accepts a proton. So when it gives a proton, it's acting as an acid. So if this is acting as an acid, this is the conjugate base of this base, which means what in terms of basicity? Which one is a stronger base?
The one on the left there is going to be more basic.
The conjugate base is always stronger than its conjugate. So then this makes NH2 minus the conjugate base of this one, meaning this is stronger than this one. Then this makes N3 minus the conjugate base of this one. So this is still a stronger base. So we already started with a base. We got stronger, stronger, and then even stronger. So this becomes an extremely strong base as compared to the measure for strong base or weak base, or the Kb of 1. So N3 minus is the strongest base. And that's choice A, and that is the end of passage 1. What are you doing?
Oh, you scared me. I'm looking at passage 2. Seems to be all about nuclear physics.
But that stuff's not on the MCAT.
You're right. I knew that. You mind if I take this one?
I was hoping you'd do some work.
Excellent. We're looking at AAMC's Test 5, Passage 2 in the Physical Sciences section. Let's look at question number 7. Question 7 reads, according to the passage, the energy released when an atom splits comes from. Now this question gives you a little bit of a hint as to where to find the answer. It says according to the passage, which means the answer must be found where, John?
In the passage thread, look.
That's where I'd look too. Let's look at the second paragraph. It says there's a large repulsive force between the positive charges in the nucleus, right? So there's two positive charges that want to move apart. There must be something in there that's holding them together as well. Let's see, the energy released when an atom splits comes from, so this is an atom that is split, the energy must be coming from those repulsive or positive charges repelling each other, wouldn't you think?
Makes sense.
Let's find the answer that says that. A says fast-moving electrons, that's not it. Short-range attraction, no, that's the opposite. Mutual attraction is the opposite. Best answer here is D, mutual repulsion of the fragments. D is the best answer for 7. Let's look at question number 8. A nucleus splits into two fragments that have equal charge but unequal mass. Which of the following is equal for the two fragments as they move apart? So we've got two particles. We've got a large particle and a small particle. And the force on each of them is the same because the force from this little particle on this big particle is the same as the force on this big particle from this little particle.
Newton's third law.
Newton's third law.
Equal and opposite forces.
All right, good deal. Let's look at it. That means that the force that is pushing this particle outwards is equal to the force that is pushing that particle in the opposite direction. Let's find the answer choice that says that. A says the magnitude of the force of one fragment on the other is equal to the other. They're two equal forces. The other answer choices here, magnitude of the accelerations, we're going to see a problem in a little bit that seems to answer the question and may have trapped you. We'll look at that one in a little bit. Speed and kinetic energy, we've got two different sized particles that will move apart with the same force. When we cover that other problem coming up in a little bit, we'll see that those two can't be right. A is the best answer for 8. 9 says based on the passage again. John, if it says based on the passage, information must be where?
Must be in the passage.
I love questions like that. Why are there no naturally occurring elements that have more protons in their nucleus than uranium does? So the question is, why are there no naturally occurring elements that are larger, in a sense, in their nucleus than uranium is? Well, if that's true, or if that's the point that we're trying to find out, it must be something about this mutual repulsion of fragments within the nucleus. We've got these positive charges that are trying to repel each other. And if we consider just a uranium nucleus, what must be happening is that's the maximum number of positive charges that we can throw into a nucleus. If we tried to throw one more positive charge in there, what would happen?
I think it would just break apart.
It would just blow up. It would say, I can't do it anymore. The force that's holding them together can't hold them together. Let's find the answer choice that says that. A says all of the heavier elements have radioactively decayed. Probably not the right answer. I mean, essentially what the question is asking, we got to read it very specifically here, is it says, why are there no naturally occurring elements? Well, A doesn't really answer the question in my opinion.
And it's not in the passage.
Yeah, exactly. It does say based on the passage, so the answer's got to be there. B says all of the heavier elements are stable. Well, that's got to be wrong because it's wrong. I mean, it's the opposite of the right answer. C says the range of the strong nuclear force is too short to hold them together. Referring back to paragraph 2 there, paragraph 2 talked about the repulsive force, and then just immediately below that, it talks about the attractive force, the strong nuclear force, which is holding them together. C answers the question very well. We can't put another positive charge because now this force is not going to be strong enough to hold the nucleus together. C must be the right answer. 10, and moving on. Says, which of the following graphs best illustrates how the force between fragments from the fission of a uranium nucleus varies as the fragments move away from each other? In other words, as the particles move apart, which is going to describe the force on them as they move apart? Can you hold it a little bit more? You know what, I'll do it over here. What's the formula I'm going to use here? We got force due to an electrostatic attraction or repulsion. And if we look at that formula, and this is a must-know formula for MCAT, I'll put a little asterisk there, you must know this formula. What we should see is that these two particles, or they can be any size, as the two particles move apart, as the distance or the radius between them increases, the force is going to go down how, John?
Inversely to the square.
Inversely to the square, which means we're not going to have a straight line graph, and it means that we're going to have as radius goes up, the distance between them goes up, the force goes down by a lot. That's the best answer. Let's find the answer choice that says it. A is definitely out because we got force and separation increasing linearly. B is out because they're both increasing. C is out because they're decreasing
Linearly.
linearly. What's that graph about? D must be the right answer because as the separation increases as we go here, the force is going to diminish exponentially. Best answer for question 10 must be answer choice D. Thanks, John. 11. And you can see, really, if you look at this passage and all the questions here, really they're pounding this point of Newton's force laws, but also this idea of this repulsive force within a nucleus due to these electrostatic things. 11 says, if they're given enough energy, nuclei of lighter atoms, in other words, smaller atoms, we got two smaller atoms, if they're given enough energy, we can actually fuse these things together. Which of the following best explains why this energy is required? Well, obviously, we've got two small atoms. Each one in their nucleus is going to have what kind of a charge, John?
Positive.
Positive charge. We've got
protons.
two positive charges from the protons. Two positive charges. We're trying to jam them together. We've got this repulsive thing going on. We need that energy to overcome that repulsive force. Let's find the answer choice that says that. Oh! A says to overcome the mutual repulsion of the nuclei.
That must be it.
God, I love it when it works out so easily.
Let's move to question 12.
Thanks. If a uranium nucleus undergoes fission, as shown in figure 1, as one fragment moves away from the other fragment, it has. Now, just a point on that. If you didn't know what fission was, right, this one tells us in the question, it tells us that fission means that the nucleus is splitting apart. So we got a nucleus splitting apart, which means we must have two fragments from that nucleus moving away from each other. We already know that as those two fragments move away from each other, that the radius or the distance between them is increasing. And as that distance or radius increases, what happens to the force, John?
It goes down.
So we've got a diminishing force as these two particles move away from each other. If we throw up here Newton's second law, oops, I forgot. Newton's second law?
F equals ma.
F equals ma. We'll have fun with it, but you can't forget that formula. This must know for MCAT. F equals ma. As the force diminishes, obviously the mass of these two particles is not going to diminish, so something else must diminish. What's that? It must be acceleration. The acceleration, as they move apart, because the radius is increasing, the acceleration must diminish. Let's find the answer choice that says it. A is out, constant speed. B is out, says constant acceleration. C says decreasing acceleration. D says increasing acceleration. Best answer, diminishing acceleration. Answer choice C.
You know, that was really good, and we didn't really have to know anything about nuclear physics.
Amazing, isn't it?
Amazing. Oh, wow, what were you eating last night?
Oh my God! Haven't you read passage 3? It's all about chlorofluorocarbons, and here you are polluting our set. John, have you read this passage? It's all about how chlorofluorocarbons degrade ozone in the upper atmosphere. You know what? As punishment, I think you should have to do this particular passage.
I'll do the passage. Just settle down. Okay. Jeez. All right. Let's take a look on passage 3, test 5R. Question number 13. A compound that significantly assists in ozone depletion cannot be. This kind of question I look at and I say, I don't know anything about ozone depletion, obviously. So I look at this, I think the answer must be in the passage somewhere. If we take a look, it says in the actually last sentence in the second to last paragraph, they cannot undergo photolysis in the upper atmosphere. So therefore, it must be something that can't happen in the upper atmosphere. We take a look at answer choice D. The compound cannot be inert in the upper atmosphere. So D is the answer.
Best answer.
Number 14. The chlorine atom in reaction 4 is very reactive because it has. Take a look at reaction 4. When you see the little dot there by the chlorine, here's the chlorine and here's a little dot. What is that dot?
That's an electron.
That's an unpaired electron, which makes this a radical. So radicals, you need to know for the MCAT, are very reactive.
Got it.
The chlorine atom in reaction 4 is very reactive because it has an unpaired electron, choice A. Number 15. Which of the following is the balanced net reactions that is described by reactions 4 and 5? If we pick up the diagram here, we see 4 and 5. Now look what's happening. We have the chlorine radical as a reactant and as a product. That goes. We have O2 as a product and a product, so we're going to have two O2s over here. The ClO radical is a product here and a reactant here. That's going to go out. What are we left with? O3 plus O goes to 2 O2. We take a look, and that is going to be choice B. Thank you, Vanna.
You got it.
Jordan. Let's go to question 16. Based on table 1, which of the following graphs most accurately depicts the free energy changes during the course of reactions 1 and 2? Let's take a look at reactions 1 and 2.
Hey, how'd that get on the board?
The magic of television.
Ah.
Okay. Now, if we take a look at reactions 1 and 2, and they're asking what happens from beginning to end. So we're going to add these reactions together, just like we did the last question. So this O is going to cancel with this. Notice we've got two O2s, and that's going to go to O plus O3. Then they're going to ask us for Gibbs free energy, or so the free energy change, which is Gibbs free energy. So we're looking for the delta G. From table 1, thank you, Jordan, we take a look, and our reactant is O2. And O2 has how much Gibbs free energy?
According to the table, 0.
Yeah, and this is the Gibbs free energy of formation. And then we have the products are O and O3, and what is the free energy of the products?
163 for O3 and 230 for O.
So higher. So we're going to go on the graph, we're looking to go from low to high. Okay? So if we take a look at the diagrams, we see that A is out because they start at the same level, and B is out because we drop. C or D, low to high, low to high. Either we have this hump in the middle or the dip. This will never happen. You always have an energy of activation for any reaction. You always have a hump in the middle. Answer choice is C.
That looks more like a roller coaster. D does.
Okay, question 17. According to table 1, what is the delta S of the following reaction? Delta S is the entropy change. If we take a look at table 1, we see that the reaction starts with O3, and entropy is 238, and it ends with O2, which is 205. So if I write those on the board, 238, let's just call it 240. Is that fair?
That works for me.
Because on the MCAT, we're going to round our numbers. And then we go to the product.
205.
205. Okay. It looks like a drop. Would that be correct?
It wouldn't be correct because what's going on is we start with 2 moles of O3 and we make 3 moles of O2.
And how do I know to use that little coefficient there, 2 and 3? How do I know when to do that and when not to? Let me suggest a way. We take a look at the units of S, and the units are joules per mole Kelvin. So if it's per mole, we need to multiply by the number of moles. So there are 2 O3s, and there are
3 O2s.
O2s. Okay. Then we do this as products minus reactants. Here are my products, 3 times 205. Let's see, that's about 615, and my reactants about 480. So I end up with 615 minus 480, which is roughly, my math is bad, 135. And do we have an answer there?
D.
D. Now, how do we know it's positive and not negative?
Well, because the value you calculated was positive.
Exactly. Products minus reactants. Okay. And then the last question, question 18. From reactions 3 through 5, what can be determined about the relative concentrations of CFCs and O2? Jordan, where are the CFCs here?
That would be this thing right here.
Because why?
That's a chlorofluorocarbon.
Good. So we have
that was the
carbon,
thing you were spraying all
chlorine,
around.
and F. That's right. That's what I was spraying. And I've learned my lesson. Thank you. Now, if we look at reaction 4 and 5, what do we see happens when we add one of these? What can happen? What can happen is this reaction creates a chlorine radical, which goes to here. The chlorine radical then reacts with ozone, breaking it down to O2. We get this chlorite radical, and that reacts with O, recreating our chlorine radical. That chlorine radical then can come back here again and react with the O3, and we get a chain reaction. And so it just continues on. So what we end up having really is that chlorine radical becomes a catalyst. Let's see if we have an answer choice that says that. Answer choice C, a catalytic amount of CFC can produce much O2. That's passage 3. All right, we're on passage 4. Let's discuss the chemistry of fertilizers.
Oh, God, let's not.
Why not?
Because this passage is not about fertilizers. I mean, they mention them a little bit, but it's really just application of general chemistry.
No, you're right. Why don't you show us?
Okay. Thanks, I will. Question 19 says, after adding the fertilizer shown in equation 2 to the soil, what will be the most likely effect of excessively moist soil conditions? John, would you bring up equation 2?
Certainly.
So the question says excessively moist soil conditions. Now that's going to mean soil with some water in it. And if we look at equation 2 here, what we've got is we've got our reactants on the top and we've got our products down here. Excessively moist would mean lots of water. If we increase the amount of water as a reactant, what's going to happen, John? We're going to push the equilibrium
to the right.
Okay. As an application of Le Chatelier's principle, if we increase the reactants, we're going to push the equilibrium and form more products. So that's the answer choice that we have to find. Let's look at question 19. They trick us. They present the answer choices in a way where maybe we're not used to seeing it, right? The question here says, each answer choice says, the degree of ionization. Well, let's look at it. Over here we've got our reactants. Each one of these is not an ion. In other words, there's no charge in their entire molecules. But over here we've got, let's see, we've got a charge here, we've got a charge here, and look down here, we've got another charge. So as we form more products in this reaction, the degree of ionization goes up.
Increases.
All right. So let's find the answer choice that says that. We are now increasing the amount of H2O, a reactant, pushing the equilibrium towards the product. We know that increases ionization. Best answer choice. Let's see, we know the ionization will increase. That is going to eliminate answer choices C and D. They're talking about a reduction in ionization. Then between A and B, A says the degree of ionization will be greater, producing more OH minus ion. We increase this. Le Chatelier says push it that way. We're going to increase the production of OH minus ion. So A sounds good. Let's just check B because we're here. B says the degree of ionization will be greater, consuming more OH minus. Wrong. No, that would be the opposite of what's true. Best answer for this one, 19, is A. Thanks, John. 20 says which of the following is the most likely reason that plants cannot utilize nitrogen from the atmosphere? So just a little clue on when you're dealing with the MCAT, anytime you see the word cannot or accept or anything that would sort of exclude right answer choices, my recommendation is that you remember to take your pen or pencil and physically write a line underneath that so that it highlights in your brain that you're dealing with a cannot or an accept type question. So we're going to look for the answer choice here that doesn't fit, essentially. And you want to give yourself a clue in that neighborhood. A says N2 is present in very low concentrations in the atmosphere. So what is the presence of nitrogen in the atmosphere?
79%.
70. So would that be very low?
I think that's high.
Yeah, that would be like the opposite of very low. And this is probably a value that you should memorize. Nitrogen approximately about 79% in the atmosphere. So A, not right. N2 is two polar. If we look at N2, we've got one N here and an N here, and they're going to be connected by three, count them, 3 bonds. Well, obviously, each one of these has a similar electronegativity to the other. Is this a polar bond?
No, you have to have a difference of electronegativity.
Yeah, you'd have to have different atoms and a different electronegativity. B is out too. C says N2 is very unreactive because it's a noble gas. Well, I don't have a periodic table with me here, but
it's not in the last family.
Yeah, no way, right? Good. No. So C is out, and then that's going to leave D because we've eliminated the others. Let's just check it. N2 is very unreactive because of the great strength of the N-N triple bond. Well, you need to know that when you have 3 bonds, that's stronger than a double bond, that's stronger than a single bond. N-N, very strong bond, not very reactive. D is the best answer. Question 21. In equation 1, HPO4 2- is the conjugate. Now note, this is really a kind of a simple question, but the way that they ask it makes it seem much less simple. In other words, they could set us up, for example, with H2PO4 1- and say, what is the conjugate base of this acid? But they don't ask the question that way. They ask it in a funny way, which I think is designed, to some extent, to confuse some of the test takers.
I'd agree.
Okay. So let's look at it. This question says, this is the conjugate. The conjugate what? Let's see. Obviously, it doesn't have anything to do with answer choices A and B because those both talk about NH4+. So it's not going to be an acid or a base conjugate of NH4+. So those two must be out. Answer choice C then says it's the conjugate acid of H2PO4. Well, we just drew it. This is in fact the conjugate base of this acid, so C cannot be the correct answer. We look simply at D, it is the conjugate base of H2PO4-. Truism, that is a true answer. Essentially what you do is when you look for the conjugate base of an acid, you remove a proton and add an extra negative charge. Cool. 22 says, which of the following equilibria best accounts for the pH raising effect of calcium carbonate? So we're looking for an answer choice here that's going to raise the pH. John, if we're looking to raise the pH, what do we got to do to the number of protons?
Protons go down and OH- goes up.
So we either got to find an answer choice here, we're going to decrease the number of protons or increase the number of OH- ions. Let's look at it.
I agree.
Well, answer choice A really doesn't discuss the question specifically or directly. It talks about calcium carbonate breaking into calcium and carbonate ion. Doesn't answer the question directly. Notice that B, C, and D all have OH- ion as a product. Those are the answer choices I want to focus on. And if we look at it, we've got answer choice C, for example, has carbonate ion. In other words, we can talk about the calcium carbonate salt dissociating into a calcium ion and a carbonate ion. And John, when you see that carbonate ion, what does it make you think about?
Carbonic acid and HCO3-.
Awesome. Yeah, it's a good idea that you recognize this carbonate ion. Why? Well, in physics, because it's going to act as a base, but in biology, because it is the final product of the dissociation of carbonic acid. And the intermediate here is going to be HCO3-, and then we're going to dissociate finally into CO3 2-. This is going to be an acid-base combination that is going to form the buffer system in our blood. So it's almost, I think you have to memorize it. I'm going to put a little asterisk here and ask you to please memorize that for MCAT. But what we can see here is that carbonate ion does, in fact, it is the conjugate base of this acid, meaning it can pick up a proton and lower the H+ concentration in the solution or raise the OH- concentration in the solution. And it would do that, as answer choice C says, by reacting with water. We got CO3 2- plus H2O, producing the HCO3- ion and the OH- ion. And you should recognize immediately OH- ion increases the pH in the solution that we're talking about. Question 23. I think this problem is the hardest of the set. And the reason it's the hardest is just the way it kind of sets up. And also, if you look at the difficulty on this question, most people who answered this on an actual MCAT got it wrong, which obviously points to the fact that it's probably a pretty hard problem. But if we look at it, let's bring up reaction 2 again. Question 23 says, in the equilibrium constant expression for equation 2, which we've got right here, in the equilibrium constant expression for this, H2O is omitted because the salt is, well, if we look at our reactants and our products, obviously one of the products of this reaction is OH- ion. So as we increase the amount of this particular salt, Le Chatelier says increase this, push the equilibrium that way, you're going to produce more OH- ion, which would mean
it's a base.
It has to be a base. So we have to eliminate 2 answer choices immediately. C and D have to be wrong because it's not an acid, it has to be a base. It increases the OH- ion production. Now the question becomes, is it strongly or weakly basic? Now there's a couple ways to answer this question. You could actually work through the science and think about the equilibrium expression here and talk about the fact that the H2O is essentially 1 and unchanged through the reaction. Or you could just say, hey, how strong does this base look? Well, it's not in my group of must-memorize strong bases for the MCAT, so my sense is, because this is a hard problem, this tends to be a problem where a lot of people are going to struggle with it. They're going to look at it and they're going to think and think and think. And what happens there is you spend a lot of time. And the problem with a hard problem on the MCAT is you spend a lot of time, and a lot of times you get it wrong. And usually, if you just apply a little bit of common sense, sort of logical appreciation to the question, you can eliminate 1 answer choice. If I see this on my MCAT, I'm going to make the guess that this is not a strong base, and I'm going to pick the weak base answer choice, in other words, answer choice A, and then the H2O nearly constant thing.
Well, you could say it's nearly constant or nearly 0, and nearly 0 would mean there's almost no water, which isn't practical. Then the reaction doesn't run at all.
Well, you got a good point there. So I appreciate the pickup.
Very good.
A is the best answer. Hey, John, I can't find the passage for this next set of questions.
Jordan, you've got to take the MCAT more seriously. Okay, I'll do these. These are called standalones. I'll do the standalones.
Okay.
At least this set. All right, question 24. I've written down the reaction for question 24. Consider the above unbalanced equation. For this reaction, how many milliliters of 2 molar solution of Na2CO3 are required to produce 11.2 liters of CO2 at STP? They've done a lot of things to confuse the issue here. First of all, they left the equation, the reaction, unbalanced. But you know what? It doesn't really matter that it's unbalanced, because if they're looking for CO2, the ultimate question is how much CO2 is produced. All the carbon in CO2 comes from where?
The sodium carbonate.
Exactly. And this is already balanced then. It's a 1 carbon to 1 carbon. I could ignore the rest. Now the next thing I'm going to look at is the 11.2. That's a big clue. Why is that a big clue, Jordan?
Because it tells us how much CO2, how many moles of CO2 gas are produced.
How do you figure?
Well, 1 mole of any gas occupies 22.4 liters of volume. So if we've only got... At STP.
At STP, and they told us STP, exactly. So if 22.4 liters is the volume of 1 mole of gas at STP, 11.2 liters at STP is the volume of?
Half a mole.
A half a mole, exactly. So we're getting a half a mole of CO2, and that means we started with how many moles of sodium carbonate?
1 to 1, so it must be half.
Exactly. All right, so we've knocked out probably the hardest part of that question. Now, how many milliliters of 2 molar solution of sodium carbonate are required to produce 1/2 CO2? So how many milliliters is 1/2 a mole of 2 molar NaCO3? Now, the way I like to do this is I take the 2 molar solution, 1 liter would be how many moles?
2.
1 liter would be 2 moles. Well, how much would a half a liter be?
Quarter of a mole.
If 1 liter is 2, half a liter would be 1 mole. Jordan was never too hot on the math here. Are you with me, though? If 1 liter is 2 moles, then a half a liter is 1 mole. Am I there yet? No, I want to get to a half. So half of a half a liter is a quarter of a liter. A quarter liter, then, is a half a mole. And a quarter liter is 250 milliliters. Answer choice B. Okay? Let me just go over that one more time. If 1 liter is 2 moles, a half a liter is 1 mole, a quarter liter is a half a mole. And there we are. All right, let's go to question 25. By how much does the oxidation number of manganese in MnO4- change when we go to Mn2+? And here you just need to know that each oxygen is a -2. And if each oxygen is a -2, this is a 4 here, MO4, then we have a total of a -8 for oxygens. We need to bring this whole molecule back up to a -1, so manganese here must be a +7. And that would give us our -1 for that whole molecule there. And then we got to bring that, we're going to go from there to a 2+. So we go from a +7. Now, notice 2+ is the ionic state, the charge. +2 then is the oxidation state. So from a +7 to a +2, that's an increase of 5. Answer choice C. Question 26. I hate the way this question is worded. If ocean waves strike the shore every 3 seconds and the horizontal distance between adjacent crests and troughs is 1 meter, what is the average speed of the waves? So if we take a look here at our wave, when they say the horizontal distance between adjacent crests and troughs, they're talking about this distance. Now you may have thought that it's this distance, right? The horizontal distance between crests or troughs, but what it turns out they're talking about is this distance. Unfortunately, the way the question's worded is, you're just going to have to hope you pick the right distance here. Now they're saying every 3 seconds, a wave strikes the shore every 3 seconds. So it's 1 wave. What's another word for a wave?
Cycle.
Cycle. 1 wave or cycle per 3 seconds. And a cycle per second is the frequency. They're asking us then, so we know the frequency is 1/3, and now this is an equation you need to know for the MCAT. So as Jordan does, I'll put a little asterisk by this equation. Velocity equals frequency times wavelength for a wave. We know the frequency is 1/3. We know the wavelength. What is the wavelength here?
Well,
if this is
that
1
distance
meter,
is 1 meter, so a wavelength would be 2 times that distance.
right,
2
from peak to peak. Very good. 2 meters. So wavelength is 2, gives us a velocity of 2/3 or 0.67.
Yeah, the
Answer
difficulty
choice
really
B.
points out the strangeness in the wording of that question. That 31% of people who actually saw that on an MCAT got it right according to MCAT statistics, and I think a lot of that was about how they worded it.
Exactly, seeing that not knowing if the adjacent distance between adjacent crests and troughs was this distance or that distance right there. All right, let's go to question 27.
Oh, that's a hard problem.
A particle is moving on a circular path whose radius is 4 centimeters. So here's my circular path, and my radius is 4 centimeters. How long will it take for the particle to move through a distance of 16 pi centimeters along the circle? So let's figure out first of all, how far is 1 time around the circle? What's the formula for a circumference of a circle?
2 pi r?
2 pi r, which makes it 8 pi is 1 time around. So twice around would be?
16 pi.
16 pi. Okay, so 2 times around gives me a distance 16 pi. If I can figure out how long it takes this thing to go 2 times around, I've got the answer. It tells me that it moves with a frequency of 4 hertz, and a hertz is a cycle per second. So that means it moves with 4 cycles, 4 times around each second. Now how many times do I have to go around to get 16 pi?
Twice?
Twice around. So if I go 4 times around in 1 second, how long is for twice around?
Half that.
Half that, which would be a half second. Answer choice B.
Hey, that wasn't so hard a problem after all.
Not bad.
D is for dinosaurs. E is for elephants.
Jordan, I told you when you took that night class you might find the homework challenging.
All right, go ahead and laugh. But what you don't see is that I'm doing the same thing that the chemists do in passage 5 here. See, they take a bunch of small molecules and string them together into a large molecule. All I'm doing is taking a bunch of letters and stringing them into a large molecule, like it's a polymer, a polyletter train.
Very good. Why don't you do the passage?
All right. We're looking at passage 5, AAMC's Test 5R, Physical Sciences section. 28 reads, what mass of CDP is in 10 milliliters of the buffered solution at the beginning of experiment 1? According to the passage, experiment 1, the chemist dissolved 16 millimoles of CDP in a solution, and that's in a 1 liter solution. And according to the question, the molecular weight of CDP is 400 grams per mole. Now, all we really have here is a math problem. We got to do a little stoichiometry. Is that how you pronounce that word? Stoichiometry?
Close enough.
Works for you? Good. What we need to do here is we need to calculate the mass, because the question asks specifically what is the mass of CDP in 10 milliliters. So we start with millimoles. We've got 16 millimoles, and that's in 1 liter. We've got to multiply then by the molecular weight, which will give us grams per mole. We've got 400 grams per mole. And then we've got to multiply by the number of liters in the question. This question is asking about for 10 milliliters, which would be 1 times 10 to the minus 2 liters. If we multiply this thing here stoichiometrically, we're going to eliminate the liters, we're going to eliminate the number of moles, and we're going to wind up with grams. Now the thing here is, and I think a lot of people get trapped by it, they forget about that little millimole when they set up the problem. That millimole would indicate that we're dealing with 16 times 10 to the minus 3 moles. Let's do the math. 16 times 400 gives us about 6,400. We got to incorporate our 10 to the minus 3. The 10 to the minus 3 and the 6,400 will cancel to give us 6.4, which will then multiply by 1 times 10 to the minus 2. 1 times 10 to the minus 2 to give us 6.4 times 10 to the minus 2 grams. Best answer, C.
So that was much easier than I thought it would be. You just used units to solve it.
Yeah, that was helpful, definitely. Question 29. As an alternative to experiment 2, the chemist can also improve the yield of polymer obtained in experiment 1 by increasing the amount of. Now to answer this question, I want to look very closely at the formula. What we've got here is equation 1, and we're looking to increase the yield of polymer. Well, the polymer is this product right here. It was the entire alphabet train in our alphabet train example. This is a product of the reaction. If we want to increase that, we could simply apply Le Chatelier's principle.
Wait, so let me just get this straight. In your example, each card was a CDP.
Exactly.
Right? And there were n number of cards. So there were 26 cards because 26 letters of the alphabet. And in the end, after it all reacts, there would be one train with 26 CPs. Got it?
Yeah, you like the alphabet train example.
I like it better now.
Good, all right. So according to Le Chatelier then, if we wanted to increase the amount or the yield of the polymer product, we've got to increase the amount of reactant here. And Le Chatelier would tell us that that would push our equilibrium to the right, increasing the yield of this product. Increase the amount of this, increase the yield of that. What's the best answer? Well, the only one of the 4 answer choices that includes an increase in the amount of reactant is answer choice D, CDP. Best answer for 29 is D. Question 30 really asks us one of the most straightforward and most important questions in all of chemistry on MCAT, and that is, what is this formula? K sub EQ. And I'm going to put a little asterisk above it because you must memorize this formula. If you don't memorize any other formula in all of chemistry, memorize this one. And it is simply, in square brackets, the molar concentration of products over reactants raised to an exponent, and we'll talk about that in a second. Let's look again at equation 1 here. And we've got, what are our reactants in this equation?
CDP.
The CDP is going to be a reactant, and we've got an N here. So if we'll start with the lower half of the fraction here. One of the reactants of this equation, or this reaction, is going to be CDP. And because we've got a coefficient in front of it, when we express it in the equilibrium expression, we have to put that coefficient above. In other words, that coefficient must be represented as an exponent. Obviously, we've got CDP raised to the N. That's going to eliminate a couple of answer choices. That would eliminate answer choice C. I said a couple, 1. I'll take what I can get sometimes. And then the products of this reaction are going to be CP. So molar concentration of CP, we're going to put a bracket around that. And now that's a pretty long CP. Let me just erase some of this other stuff going on.
And that narrows our answer choices already to A or B.
So we narrowed it down to A or B. And the thing about that is the CP going to have an exponent above it? Does
It's
it have a
not
coefficient?
because it has no coefficient. The coefficient is 1.
Excellent. Coefficient here will be 1 and essentially drops out of the math part of the expression. So all we got to do now is account for our other product here, and that other product will be HPO4 2 minus ion. HPO4 2 minus ion. And how many, what is our exponent there, John?
The coefficient is n.
Okay, which will make the exponent here n, because again, what we're going to do in this expression is bring the coefficient up into the exponent position.
And that's choice A.
A. Thanks.
All right.
I think we can actually continue to use that or refer to it. 31 then says, according to equation 1, the concentration of the polymer with respect to HPO4 2 minus is, okay, actually we could just use what's going on up here. What we've got is, this is the polymer, this is the alphabet in our alphabet letter train example, and this is a byproduct of this reaction, right? So we're looking for the ratio of this product to this product in this reaction. Well, in our first example, if we started with 26 letters in the alphabet, John, how many alphabets do we end up with?
1 alphabet.
And how many byproducts of the reaction?
1 for each letter, so 26.
26. So we got a 1 to 26 ratio. What if we had an alphabet that only had 10 letters in it? We start with 10. How many polymers do we end up with?
Well, 10. Oh, 1 polymer.
1 polymer, good.
But
And how many byproducts?
10.
10. So the ratio here of this to this is 1 over n. Let's find the answer choice that says that. 1 over n times this byproduct. The only one that says that is 31 is C. And if that doesn't totally work for you, what I'd suggest is you go ahead and plug in a few other numbers in there. Plug in a few other numbers for this. In other words, 100, 1,000, 536 if you wanted to. Assume you got 1 polymer product and find out how many of these you'll have. And you'll see that that ratio stays consistent. 31 is C. We're looking at question 32. 32 says, the pKa for the dissociation of H2PO4 minus to HPO4 2 minus is 6.7. And the question asks, what is the initial ratio of HPO4 2 minus to H2PO4 minus in the buffer solution in experiment 1? Say that 100 times fast. Very difficult to say. In experiment 1, it tells us that the pH of the solution is 8.7. And what I'm going to do is I'm going to take out the Henderson-Hassbach equation. And this is not necessarily a must-know formula for MCAT, but you should definitely understand it and be able to apply it if you have to on MCAT. Essentially, the Henderson-Hassbach formula reads, pH is equal to the pKa plus the log of A minus, or the conjugate base concentration, over the acid concentration. Now, the way that this can help us, and the way it helps us usually using the Henderson-Hassbach equation, is we know that the pKa for any given acid is a constant. And using Henderson-Hassbach, we can determine the pH if we know the concentration of base to acid. In other words, this is a constant. We can calculate pH given this ratio. According to this question, the pKa, the constant value for this acid's pKa, is 6.7. Which means we've got, according to Henderson-Hassbach, 8.7 equals 6.7 plus
must be 2.
plus 2. Good. So this 2 describes what's going on in this last part of this expression. Now, the thing to remember about H plus concentration, or acidity and basicity, or the pH scale, is that it's a base 10 logarithmic scale. In other words, a difference of 2 does not indicate that you have twice as many. Instead, it's logarithmic. So you have 10 squared as many this to this.
So 2 is equal to the log of 10 squared.
Exactly.
And then 2, okay, I got it.
So we've got a 100 to 1 ratio of one of these to the other.
Right. One other thing you can do is look at the difference and know that pH, every pH step is a factor of 10. So the difference between 8.7 and 6.7 is 2 pH steps, and each one's a factor of 10, so 10 times 10 is 100. Answer choice C.
Awesome. I just need you to tell me how old you are. No, I mean, you know, if we're going to go out, I need to know how old you are. Well, I just think that'd be appropriate.
Jordan, that's not polite.
Shh. John, I'm trying to date this carbon atom, and I want to find out how old she is first.
You're doing passage 6, aren't you? Practice test 5R. Okay, let's go to question 33. The carbon-14 atom undergoes beta decay to nitrogen-14. What particle is being emitted from the carbon nucleus? So this is radioactive decay. We start with a carbon-14, and this 14 means?
The mass.
Right, and it's the protons plus the neutrons. And we go to a nitrogen-14. Same number of protons plus neutrons. How many protons in a carbon?
6.
6. And then a nitrogen?
Must be 7.
Must be 7. So we increase the number of protons. Now the thing about radioactive decay is, remember, we can't change the charge of the universe. So if we increase the number of protons, we've added a positive charge. What else do we need to add?
Negative charge.
We've got to add a negative charge, right. So this must be a beta decay. We must be emitting an electron. Answer choice A.
Got it.
Question 34. Archaeologists find an object that is known to be created 18,000 years ago. Measurements indicate that 1,000 atoms of carbon-14 are present in the object. How many atoms of carbon-14 were present when the object was made? This is a half-life question. You really should do this on your fingers. We take a look in the passage and see that a half-life is 6,000 years. So we just want to find out how many half-lives have taken place, and then we can find out how many atoms we have. 18,000 years ago, that would mean we have 3 half-lives, because 6,000 years for each half-life. So if we have 3 half-lives, and it tells us that measurements indicate that 1,000 atoms are present in the object. So at the end of 3 half-lives, we have 1,000. A half-life before we had 1,000, we had 2,000. A half-life before that, we had
4.
Twice that, 4,000. And before that?
Twice that, 8.
8,000. We take a look, answer choice D. It's on your fingers. Figure out how many half-lives and then count them out. Okay, question number 35. The average velocity of a beta particle ejected from a carbon-14 is 3 × 10 to the 7th meters per second. What is the average kinetic energy of this beta particle? Okay, so kinetic energy, this is a formula you have to know the equation for. 1/2 mv squared, kinetic energy. We've got V, which is 3 × 10 to the 7th, and we'll square that. And then what is the mass? How do we find the mass?
Well, they tell us in the passage, last paragraph.
Right, and we don't have to know the mass of a beta particle, which is really just an electron. You might know that it's 10 to the negative 31st, 9 × 10 to the negative 31st, but they tell us in the last passage. So it's 9 × 10 to the negative 31st, and this will be my kinetic energy. So if we take a look here, we're going to have about 27 times 1/2, so let's call that about 14. Oh, you're right, I got to square it. Thanks, Jordan. Almost missed my first MCAT question. Okay, so when we square this, we got to square the 3, so that's 9 × 10 to the 14th times 9 × 10 to the negative 31st times 1/2. So 9 times 9 is 81 times 1/2, so we have about 40 times 10 to the negative 31st and 10 to the 14th. What do we do with exponents?
Add.
We add them. So 14 plus 31, we get 10 to the negative 17. Okay? Now let's put this into scientific notation, proper form, 4.0. If we divide by 10 here, we need to multiply 10 by 10 here, so we get 10 to the negative 16th.
C.
And answer choice C. Very good. Question 36. The best materials to use as scintillators are nearly transparent to the wavelengths of the light that they emit. This characteristic is important because, now when I think about scintillators, I didn't study scintillators for my MCAT prep. Did you?
No.
So I don't need to know anything about scintillators. So I go back to the passage to see what they tell me. And they tell me a scintillator is a substance that produces light. So if I'm looking for something that produces light, I see from answer choices A or B, they're talking about reabsorption. I don't want it to reabsorb the light that it produces because I want the light to be produced. So answer choice A, it minimizes the reabsorption of light. What about choice C?
That seems to be the right answer because the more light you produce, it would seem to agree with what's going on in the passage.
Right, right. So, and it's not because?
Because it says in the question that the best materials to use as scintillators are nearly transparent to the wavelengths of light that they emit. So you want the scintillator to be transparent so light will easily move through it and not minimize the reabsorption of the light produced by it.
Exactly. So the reabsorption part of the light is more important. Okay, so 36 is A. 37. When the wavelength for maximum light emission of a given scintillator is 450 nanometers, what is the energy of the light photon? So here, this is an equation that you have to know, and it is energy equals Planck's constant times frequency. You don't have to memorize Planck's constant, they'll give it to you. They give us Planck's constant as 6.6 times 10 to the negative 34th joule seconds. and then frequency. Now we don't have frequency. We're looking for energy, but we don't have frequency. What are we going to do to find frequency?
Well, we know that the speed of light is c, or 3 times 10 to the 8th.
All right, another formula. The speed of light, c, equals frequency times wavelength, which is that same formula as v equals f lambda. And they've given us lambda, and lambda was
450 nanometers.
450 nanometers. Now, can I just leave it in nanometers?
No, I'd convert to meters.
It converts to meters because meters is the SI unit, and the answer is in SI units, or joules. So 450 nanometers is 450 times 10 to the negative 9th meters. And then times frequency equals, and the speed of light is?
3 times 10 to the 8th meters per second.
And I need to know that. 3 times 10 to the 8th meters per second. So F then is equal to 3 times 10 to the 8th divided by, I'll bring this over here, 450 times 10 to the negative 9th. Okay, so here's my equation. Now when you get this kind of stuff on MCAT, remember we're going to take the mantissa portion and do that separately. So we basically have, let's call it 7 times 3 over, and I'm going to put this into scientific notation, over 4.5 times 10 squared, right? This will go 4.5 times 10 squared. So that 4.5, I rounded this up, so I think I'll round my denominator up as well. We'll call this 5. Now I'll do my exponents, and I have 10 to the negative 34 times 10 to the 8th, and the denominator I have 10 to the negative 9th and 10 squared. So I get 21 divided by 5.
It's 4 plus
About 4 times, and then negative 34 and 8.
10 to the minus 26.
10 to the minus 26 over
10 to the minus 7.
10 to the minus 7. And when I divide negative 26 and negative 7, I subtract. So negative 26 minus negative 7 is negative 26 plus 7. So I get 4 times 10 to the negative 19th.
The only one that's close is A.
That's right. And notice we can do the rounding here, and it's much easier to round. If I'm dealing with 6.6 and 4.5, that's a problem. So it just slows me down. I want to round on the MCAT.
Good. It's probably important to note, I probably would have set the math up differently, but I would have come to the same conclusion. As long as you're coming to the same answer, really doesn't matter exactly how you set the math up. You should be rounding though. Hey John, you ready to work on passage 7?
Okay.
Excellent, let's get to it. Question 38, passage 7. Copper attains a different oxidation state when it reacts with chlorine gas than when it reacts with iodine gas because. Okay, so this question is really about electronegativities. And if you got trapped by answer choice A or B, what you did was you made an assumption. And you assumed that we were talking, or we even cared, about the boiling point of chlorine gas versus iodine gas. This will be a bad assumption to make because there's no information given about it in the passage. And John, have you memorized anything about the boiling point of chlorine or iodine?
I haven't.
Yeah, no. So A or B would have been an assumption. If you fell into that trap, understand that you did, realize that you did, and don't do it again. Let's look at C and D, though. We got two answer choices. One says that chlorine attracts electrons more strongly than does iodine, and the other says that iodine attracts electrons more strongly than does chlorine. Well, now let's think about that. Chlorine appears on the periodic table above iodine. John, when we move to the right and up on the periodic table, what happens to electronegativity?
Electronegativity increases.
Good, and as electronegativity is the tendency of an atom to draw or pull electrons, if we increase electronegativity, that means we're going to increase our tendency to pull on them. In other words, answer choice C must be right. Chlorine is more electronegative, therefore it must draw on electrons more strongly. Question 39. Says, what was the most likely identity of the precipitate that formed when sodium chloride was added to the cadmium nitrate? So we've got two things that we're combining here. We've got sodium chloride and this cadmium nitrate. And what's interesting about this question, and this passage altogether really, is that if you start making some assumptions on this passage, you'll just essentially blow up because you'll fall into a lot of traps that I guess a lot of students might. Let's look at what they're presenting us. They're saying that when we mix these two compounds, the result is another compound, which is a precipitate. And all the answer choices, in other words, if we look at A through D, all the answer choices include the chlorine and the cadmium. In other words, we must be combining this chloride and this cadmium. The question is, in what ratio? Well, we can see, and we should know, frankly, that the charge on a chlorine ion is a negative charge, a -1 charge. And if we look over here, while I don't recommend, and I don't think, I don't know, have you memorized the charge on a cadmium ion?
I don't memorize the charge on cadmium,
Yeah, and
but I know nitrate.
You do know nitrate. And what's interesting about the cadmium is, if we check the periodic table, we might look, and if it was in group 2, we might get a hint. But the other hint that we get is that there's a -1 charge on this nitrate ion. And because we have 2 of them bound to the cadmium, we've got no net charge on this. That must mean that the charge on the cadmium is what?
+2.
+2. And it makes sense that unless there's some chemistry going on that we haven't accounted for, it doesn't seem that there is, it's just a simple recombination reaction, we've got cadmium must still have its +2 charge, which means it's going to be bound to how many chlorines?
Well, that'd be 2, because
That'd be
chlorine
2.
is -1.
Excellent. 2 of these, each with its -1. We've got no net charge. Best answer choice then is C. And now watch how this same kind of science repeats itself a couple of times. For example, in question 40, it says if cadmium is reacted with S, what is the most likely oxidation state of cadmium in the product? Now, we might make some assumptions about what goes on with cadmium, and there are some misleading sort of things going on in the passage. But the interesting thing is the only time in the passage that the passage talks about cadmium, the cadmium has a +2 charge. In other words, in the answer choice C in question 39 that we just answered, and also in table 2 where it has cadmium listed, it has cadmium bound to the nitrate ion. There's a little misdirection going on. Also in in table 2, nitrate ion is bound to copper, and it's funny because in table 1, copper then assumes several different oxidation states. And you might fall into the trap, again, this would be an assumption, where you're saying, well, copper does all these different oxidation states, cadmium does as well. Unless they say something specific about cadmium, don't make that assumption. In other words, cadmium has a +2 here, it has a +2 here, it makes sense. When it's bound to sulfur, it's also going to have a +2 charge. The other thing is you might consider sulfur is from the same group on the periodic table as oxygen. It's most likely going to have what kind of a charge in its, what kind of oxidation state?
2 minus.
A 2 minus charge.
-2
Good.
oxidation.
So probably if we bound this with its +2 to sulfur with its -2, we'd have a molecule that would make sense. 40, the best answer then is B. Question 41. When a strip of copper is placed into H2O, no change is observed. However, when a strip of copper is placed into a solution of HNO3 aqueous, a gas evolves. What is the most likely identity of this gas? Now, based on its difficulty, this is a hard question. So immediately, because it's a hard question, there's a couple of things you should do sort of automatically. First is, you should eliminate any answer choices that you know to be wrong. For example, answer choice B says CO2. Well, the question is, how could you form CO2 gas? Because you're not putting any carbon into the reaction. B must be wrong because we've got copper and HNO3 in a reaction, no carbon. Similarly, D is wrong because it just doesn't make sense that you'd form ozone in this particular reaction. So we're left with 2 answer choices potentially, A and C. Now, John, what's weird about this is that usually when you oxidize, when you drop something into an acid, you form H2 gas.
But if you drop a metal, often, yeah, because what do metals like to do? Metals like to give up electrons. But there's an exception. And the exception is that money metals don't like to be oxidized. Now, what are the money metals? Gold, silver, mercury, copper, and nickel. Now, nickel actually slightly positive oxidation potential, very slightly. Now, the other metals, gold, silver, mercury, and copper, don't like to be oxidized. And what that means is they have a negative oxidation potential. So if we were to write the half reaction on the board, copper solid goes to copper plus an electron, we get a negative oxidation potential because copper doesn't want to rust. We don't make money out of metal that rusts. So we want to know that this is negative. Now, what is the one to produce H2 gas?
Well, we'd take the H, which would be +1 from the water, and add an electron to it, forming 1/2 of an H2 gas molecule. And we need to memorize that the electromotive force, or the voltage associated with this reaction, is 0. Well, if you got a 0 here and a negative here, then electrochemically this reaction can't happen. You cannot form then H2 gas. C can't be right. It must be A. Let's look then at question 42. In experiment 2, is the boiling point of zinc nitrate higher than that of silver nitrate? So here we've got zinc nitrate, and we've got silver nitrate. And the question asks, which one of these has a higher boiling point? And one of the things that we have to know, or one of the formulae that we have to know in our chemistry preparation for the MCAT, is we have to know the change in temperature due to the change in the boiling point temperature of a solvent based on what solute that we drop into it. And the formula here, and this is must know, delta T, or the change in temperature, is equal to K, a constant, times molality, times something called the Van Hoff factor. The K constant is dependent on the solvent, and if we drop both of these into the same solvent, the K constant is going to be constant and is not going to change. Molality, we're going to have similar molalities, otherwise we wouldn't have a very good comparison, so we're going to have similar molalities, and what this question really brings out is the Van Hoff factor. And the Van Hoff factor talks about how many parts this salt and this salt will break apart into in solution. Over here we have one ion, and then the nitrates will break apart separately, so we'll have 3 ions formed. Over here we've got 1 ion and 1 ion, a total of 2 ions. So essentially what's going on is the change in boiling point, the boiling point increase comparison between these two compounds will be based on this Van Hoff factor. Over here we'll have a factor of 2 for Van Hoff factor, over here 3 for Van Hoff factor. These two variables will be the same, meaning which one of these two will have a higher boiling point?
Well, the zinc, because it's more ions.
Excellent. Let's find the answer choice that says that. Is the boiling point of zinc nitrate higher than that of silver nitrate? It would be yes. In other words, C and D are out. And then B is the best answer, yes, because the solute in the zinc nitrate dissociates into 3 ions, and the solute in the silver nitrate dissociates into 2 ions. Question 43. When a strip of copper is placed into silver nitrate, so here's copper, oxidation state 0 in its most common elemental form. If we drop copper into silver nitrate solution, a new metal forms. And the key here really, for me anyway, is new metal. In other words, we're putting copper in and a new metal is forming. And because the only other metal here that's listed in this question is silver, that must be the new metal formed. In other words, we're dropping this into solution and it must be reacting. Question is, how does it react? Well, a copper, if you put it into solution, is only going to react to increase its oxidation state, Cu2+. In other words, we're increasing the oxidation state of copper, or we're oxidizing. Anytime the oxidation state increases, that's an oxidation reaction. We must have concurrent reduction, meaning the silver, initially from the silver nitrate, must be being reduced to its most common, or to its elemental form, oxidation state 0. We've got a reduction reaction along with our oxidation reaction. Let's find the answer choice that says it. D says the copper is oxidized, in other words, increasing the oxidation state, and the silver, Ag+, is reduced to Ag0. Oh, hey, I'm trying to recreate the experiment in passage 8, practice test 5. A student performed an experiment to investigate the thermal and electrical properties of an iron wire. So what I've done is I've taken this copper wire, it's not plugged in, of course, and I'm going to take an iron wire and splice it right into it. Then what I want to do is I want to investigate, as the wire heats up, what kind of things happens to its resistance and the voltage across the wire.
Oh, sorry about that.
You know what? On second thought, maybe you better do this passage.
Okay. Question 44. What is the electrical power through the wire when T is 673 Kelvin? All right, at 673 Kelvin, if we take a look at table 1 here, we go down T and we see at 673 Kelvin, we see that we have I is 2 and V is 28. And that's the formula that we're going to use. Power equals IV. It's the formula you need to know. So power equals IV. I was 2 and V is 28. So we get 56 watts. Power is measured in watts. Question 45. What is the approximate density of the wire at 473 K? The volume of the wire is 5 times 10 to the negative 7th cubic meters. All right, for this question, we're going to use density, and we know that density equals mass over volume. They give us the volume as 5 times 10 to the negative, is that 7th?
Yes, sir.
7th cubic meters. And the mass is given in the passage as 4 times 10 to the negative 3rd kilograms. So 4 over 5 is 4/5 or 0.8. And then 10 to the negative third over 10 to the negative seventh. Again, we're going to subtract negative 7, so we get 10 times 4. So 8, when we multiply this times 10, divide this by 10, 8 times 10 to the third, or 8,000 kilograms per cubic meter, for question 45. Question 46. Which of the following graphs best illustrates the relationship between T and R? If we take a look here at T and R, each time that we raise R by 2, it's approximately 2, we're raising T by 100. So that's a linear relationship. Okay? Every increment here is equal to an increment here. And we take a look at the diagram then. In our diagram, the linear relationship, we start at low and go up. Answer choice is A. Okay, question 47. The ratio of T in trial 5 to T in trial 3 is approximately square root of 2 to 1. What is the ratio of the energy radiated each second for trial 5 to trial 3? Energy radiated per second is really power. And they give us the formula in the last paragraph. Power is equal to A sigma T to the fourth. Now, the two things we're really looking for is energy radiated per second and the relationship between that and temperature. And so it's to the fourth power. Now, when we go from, they have us going from square root of 2 to 1 is the ratio. So if we multiply the temperature by the square root of 2, what happens then to the energy? And we have to take this square root of 2 and we have to take it to the factor of 4. So what's the square root of 2 to the fourth power?
That would be 2.
It's the same thing as the square root of 2 times the square root of 2 times the square root of 2 times the square root of 2. So again, Jordan, your math was a little bit tough, a little bit on the weak side. But we get 2 times 2, so it's 4. So the energy ratio of the energy increase is a 4 to 1. Okay? That's a tough way to do it. That's a tough problem to do, but this is the way you have to do it with ratios, to recognize there's a relationship. They're asking us a relationship between two factors. Let's go to question 48. What is the minimum amount of energy required to increase T from 373 to 573? Okay, the heat capacity of iron is 460 joules per kilogram Kelvin. All right, in this one, they're asking us for, well, they want us to know that the formula, Q equals MCAT. Easy enough to remember.
My favorite formula.
Q equals, and I say MCAT, it's really MC delta T. And then they've given us M is 4 times 10 to the negative third. C, they gave us in the question, is 460. And then delta T is 200, from 373 to 573. How do we know not to change to degrees Celsius here?
Because it's given in joules per...
A couple things, right. The units of the heat capacity is in Kelvin. And also in chemistry, if you always go with Kelvin, you're always safe. Because the only time you ever use degrees Celsius is when there's a change in temperature, and then only sometimes. And the change in temperature in degrees Celsius is the same as Kelvin. Okay, so if we do the math here then, we have 4 times, well, let's do it this way. This is, I like to change everything into scientific notation here. So 4.6 times 10 squared and 4 times 10 to the negative third. Over here I have 2 times 4.5. That's about 9 times 4. So I end up with 36. 10 to the negative third times 10 squared is 10 to the negative 1 times 10 squared is 10. And I get 360. And closest answer is choice A. Now let's go to question 49. During trial 5, the wire was heated from 293 K to 673 K, while V was held constant at 28 volts. How did the current through the circuit change during this time? All right, if we take a look at the table here, we see that actually the voltage went from 0 to 28, but the question contradicts that. The question says it's going to hold constant at 28. Now they're asking about the current through the wire, so we're going to use Ohm's law. Voltage equals current times resistance. And voltage is going to hold steady at 28. And then we're going to plug in I at 293. Then we're going to plug in V is 28.
We're going to plug in resistance.
We're going to plug in resistance. Thank you, Jordan. At 4. So when resistance was 4 at 273, then I is equal to 7. Okay? Then I at 673,
Resistance is 14.
Resistance is 14. Thanks for helping out here, Jordan. And if resistance is 14, then I is going to be 2. So we look at our answer choices, and it decreased from 7 to 2. Answer choice D.
We're looking at the second set of freestanding questions, Test 5R, starting with question 50. It says the initial decay activity of a given quantity of radioactive element is 240 counts per minute. After 24 minutes, the activity count is 60 per minute. What is the half-life of the element? So we're starting at 240 per minute, and we're ending up at 60. One half-life would be 120. The second half-life would be 60. We've gone through 2 half-lives. If this is 24 minutes, each half-life must be 12 minutes. Let's find the answer choice that agrees with that. That would be answer choice B. John and I differ just on this one thing. He likes to do it on his hand. I feel it's better to write it. Either way, you've got to make sure you get these type questions right. Question 51 says, which of the following describes the entropy change for the sublimation of iodine? What's going on here is we've got iodine in its solid form sublimating to gaseous form. And one thing that I always look at is, I look at where are my gases? In other words, if I've got gas in the product side, as I do here, I've got an increase in entropy. If you had more gas on the reactant side, then you'd have a decrease in entropy. Let's find the answer choice that agrees with an increase in entropy. You got to know it's delta S greater than 0. 51, C. 52 just asks if you understand what the Doppler effect is. 52 reads, when a sound source moves away from an observer, the observer has the impression that the sound source is. Now the Doppler effect means as a source moves towards an observer, and it's a relative velocity, as the source moves towards the observer, the perceived frequency increases. So if the source is moving away from the observer, the perceived frequency must decrease. Let's find the answer choice that agrees with that. C, as the source moves away from the observer, relatively, we must have a lower frequency than actual. In other words, the perceived frequency goes down. For question 53, I've drawn the phase diagram for water. The question asking, as the pressure applied to a sample of water at -1 degrees Celsius, or -0.1 degrees Celsius would be a point right about here, is increased from 1 torr, in other words, it would be this point right here, to 200 atmospheres. In other words, as we move vertically here, we're going to increase our pressure. So we're moving from this point, we're going to draw an isothermic line moving upwards from at -0.1 degrees Celsius from 1 torr vertically. What will happen is our sample will move from the vapor phase through the solid phase into liquid phase. And that's what happens with water. Let's find the answer choice that agrees with that. A says vapor will become a solid and then a liquid. You should understand that water is most dense in its liquid form. And that's essentially why this graph looks the way it does. 54. A small negatively charged particle is placed near a fixed positively charged particle we'll call Q. Which of the following describes the motion of the negatively charged particle? Great, so we've got a fixed positively charged particle that we're calling Q, and then we're going to put a small negatively charged particle over here. John, opposites do what?
They attract.
So this particle is going to be drawn towards this particle. Let's find the answer choice that agrees with that. A says it accelerates away from Q. Not going to happen. A is wrong. B says it accelerates towards Q. There's our answer. Let's just check the others. C says it moves with constant speed. No. There's a force acting on this, an electrostatic force, thus an acceleration, no constant velocity. And then constant speed, essentially ridiculous in this answer choice. Best answer, B.
What are you doing, Jordan?
I'm almost ready, John.
What are you doing?
I'm looking for substance X in the periodic table.
Substance X? Substance X, that's the unknown substance X. There's no X element.
Oh, I knew that.
Okay. All right, we're on passage 9, number 55. Which of the following conclusions about XT solubility is most consistent with the data in Table 1? If we take a look at Table 1, and we take a look, amount of sample that dissolves, and that dissolves in water, we see that at every point, the toluene is more dissolves than the THF. So therefore, answer choice D is correct. XTs are more soluble in toluene than in THF. Question 56. The loss in weight as XTs are heated from 20 degrees Celsius to 700 degrees Celsius most likely occurs because. Now if we go through the answer choices, hydrogen bonds are formed. Well, now when hydrogen bonds are forming, does this create a loss in weight? And
Yeah,
it does
no.
not realistically, not a significant amount. How about when XTs are ionized? How do we know that's not true? Well, ionization means it loses electrons or gains electrons. And what is the mass of an electron compared to that of an atom?
Negligible.
It's exactly negligible. And then C, nuclei emit protons. If they did, we'd be changing the identity of the element. So A, B, and C have to be wrong. I hope D is right. Volatile components are released. And this actually happens. As we heat something, we know vapor pressure increases, and vapor pressure is actually the loss of the atoms from the solution, or the atoms or molecules. So answer choice D is correct for 56. Question 57. Electrons in which of the following orbitals of Ti can form bonds with substance X? So they're asking electrons from Ti, which ones will form orbitals? If we take a look at Ti, it's a transition metal. So it's going to form orbitals from its D subshell. And so answer choice B. Notice here that even those are the only valence electrons they even offer as an answer choice. So the question is actually even easier than it seems. For instance, had they offered the answer choice 4s, we might have been uncertain, because 4s do hold valence electrons for Ti, but they don't give us that choice, so they only give us the choice of 3D. For 57, answer choice is B. 58. Which of the following elements, if reacted with substance X, will most likely yield compounds with the same properties as the XTs described in the passage? Now, if we take a look here, we're looking for something that is similar. When they ask for similarity, we're looking for an element in the same family, because on the periodic table, because elements in the same family on the periodic table have similar chemical behavior. And if we take a look at the periodic table and we see the Ti is in the family number 4, and we go down that family, the only answer choice that is in that family is choice C, ZR. So number 58 is choice C. Number 59. Which of the following is the orbital hybridization of O in THF? Now we take a look at the diagram in THF. We go to THF, and here's O. Now oxygen has a valence of 2, so it's making 2 bonds. But what we also know that's not shown here is there's 2 pairs of electrons. So if we want the orbital hybridization, we need to count the number of pairs of electrons, right, the lone pairs, and then the number of sigma bonds. So it has 2 sigma bonds and 2 lone pairs. It's just like water, and that makes it sp3. Answer choice B. Number 59 is B. Which of the 2 solvents in figure 1 is most soluble in H2O? If we take a look at these two, Jordan, why would one be more soluble in H2O than the other?
Well, the ability to hydrogen bond, or something like a hydrogen bond, certainly a polarity might.
Exactly. Whenever we have a water solubility question on the MCAT, think about hydrogen bonding. Now, this one is nonpolar, right? We've got a benzene ring and methane, so this is very low solubility in water. This one, on the other hand, as we just said, it's something like water. It can't hydrogen bond to itself because it doesn't have a hydrogen attached to an N, O, or F. Right? So it can't hydrogen bond itself, but it can hydrogen bond to other things like to water because it does have the oxygen. So we expect THF to be more soluble. Answer choice A, THF, because THF forms hydrogen bonds with H2O, but toluene does not.
All right,
Now what?
getting ready for passage 10. What do you think?
Oh my gosh.
I need to
Okay.
take the glasses off, though. All right, we're looking at passage 10. Question 61 says, which of the following best describes the energy conversion taking place when the toboggan is sliding from point A at the top of the hill to point B at the bottom of the hill? John, before it starts sliding at the top, what kind of energy does it have?
Must be just MGH, or gravitational potential.
Potential energy, excellent. So any answer choice that starts with kinetic energy would really be wrong, unless you made an assumption. Don't do that. A and B have to be out. We're looking at C and D. And then we got C says potential to kinetic and thermal, and D says potential and kinetic to thermal. Again, to assume that we're moving at the top of the hill, I mean, just doesn't make a lot of sense. And the other thing is that C answers the question much better. The potential energy as we slide down converts to kinetic, and because there's friction with the toboggan, some of that kinetic energy, some of the original potential energy is lost to heat energy or thermal energy. Let's look at question 62. It says, which of the following expressions gives the amount of energy lost to friction by the toboggan and rider between points A and B? Now it says in the passage in the middle of the first paragraph that as the toboggan slides down the hill, it is opposed by a constant 60 Newton frictional force. So we're looking for the change in energy, which essentially we could say is equal to the work done by friction, which in this case work is equal to force times displacement, or the distance over which that force works. It's a 60 Newton, constant 60 Newton frictional force. Now we got to do is determine this D. Well, it says that the points A and B, again in the passage, points A and B are a distance L apart. So plugging in for our distance here, we've got L times 60 is equal to our work done by friction. Best answer choice is B for 62.
I agree.
Let's look at question 63. It says the sled and rider are traveling at 10 meters per second when they have a completely inelastic collision with the stationary toboggan and rider. How fast do the sled and toboggan travel immediately after the collision? Couple of hints here. First of all, because it's completely inelastic, that means that as the two hit, they stick and move together. Okay, so plugging in, or setting up the problem. We got the sled and rider, which according to, really difficult to write with gloves on. The sled and rider are a 50 kilogram mass, and it's moving initially at 10 meters per second. So what we've got here is a mass times a velocity, which is going to give us a momentum. They've got 500 kilogram meter per second units of initial momentum. Now the thing about momentum is what kind of a quantity, John? Vector or scale?
It's a vector.
It's a vector quantity, which means not only must we have a magnitude, we must also have a direction. And I'm going to say that the sled and rider are moving in this direction. You could choose any direction, but I think moving to the right here would make the most sense. It's also going to be logically easiest for you to handle. They then have a collision, a completely inelastic collision, with the 54 kilogram child and a toboggan. In other words, a 60 kilogram total mass. Initial momentum is 500. One of the things that we have to know about momentum, P initial is equal to P final. In other words, if the initial momentum is 500 kilogram meter per second in that direction, final must be the same. Final momentum then is 500. The final mass is the combination of this 50 kilogram mass and this 60 kilogram mass, so the final mass is equal to 60 plus 50, or 110, which means we can do some simple math here. Let's divide both sides by 110. The velocity must be 500 over 110, or a little bit less than 5. The only answer choice that works, A. Let's look at 64. What is the coefficient of friction between the sled and the ground when the sled and rider are to the right of point B? In other words, after they've gotten off the hill, the sled and rider are to the right of point B. If we look back in the passage, to the right of point B in the end of the paragraph, the sled and rider are opposed by a constant 50 Newton frictional force. So the force that is acting on them is 50 newtons constantly. We already know that the sled and rider together are a 50 kilogram mass. Let's just plug in. We've got the force due to friction is equal to, John, remember the formula for the force due to friction?
That's the normal force times mu.
Normal force times mu, the coefficient of friction, which happens to be what we're looking for here. This is a must-memorize formula for the MCAT, so I'll throw the asterisk in there. We know the force due to friction here is 50. We know the normal force after point B, the sled and rider are sitting on a flat surface, so the normal force will oppose their gravitational force, 50 kilograms times 10 meters per second squared, or 500. 50 over 500 gives us mu. That would be 0.1. What's the best answer?
Choice A.
Choice A. Love how this stuff works. So we're looking at question 65. From ground level, a person at point A throws a snowball horizontally to the right at 25 meters per second. Where does the snowball land? So we got a person throwing a snowball to the right horizontally, no vertical velocity, at 25 meters per second. And the question is, where does the snowball land? Now there's two things we have to do here because this is a projectile motion problem. So anytime you have a projectile motion problem, the first thing you have to do is calculate the time in the air. One is time in the air.
Because time in the air dictates how far it's going to go.
Exactly. Good. So to calculate the time in the air, we've got to go back to one of our translational motion problems. D, the displacement, is equal to initial displacement plus velocity times time, initial velocity times time, plus 1/2 AT squared. This is a must-know formula for MCAT. In other words, you have to know it. Now, we can take this formula, and because we're talking about velocity, when we're talking about time in air, we're talking about velocity only in the vertical dimension. So there's no, because the ball is being thrown horizontally, there's no initial displacement and no initial velocity, and we can say, okay, D, displacement, is equal to 1/2 AT squared, or T is equal to the square root of 2D over A.
Oh, you just did algebra there.
What?
You just did some algebra.
I did some simple algebra there to get this formula. T is equal to square root of 2D over A. Now, the ball is being thrown horizontally, and it's going to fall as it is going to fall a total of 20 meters as it travels in its arc. So it's the distance that it's going to travel is going to be 20. So we've got 2 times 20, and of course the acceleration due to gravity is going to be what, John?
10.
10. So we got 2 times 20, or 40, over 10 equals the square root of 4. The square root of 4 is, of course,
2.
2. So we've calculated that the time that this projectile is going to spend in the air is 2 seconds. So that's the first thing we have to do. And the second thing we have to do is calculate the horizontal displacement of the projectile, which I'm just going to denote x, or you could denote d, because that's the variable that we're using up here. We've got a formula for displacement, horizontal displacement. We know that the projectile was in the air for 2 seconds. Let's see. Its initial displacement, if it's starting at point A, initial displacement is 0. So this comes out of the equation. And in the horizontal dimension, anytime you have a projectile flying on the MCAT, in the horizontal dimension, there is no acceleration. There's no forces acting upon it. You should assume friction doesn't exist unless they state otherwise. No forces acting on it. We take that part out. The formula becomes displacement horizontally is equal to initial velocity horizontally, 25, times the 2 seconds spent in the air. 25 times 2 gives us 50. In other words, looking at our diagram, this snowball is going to travel for 2 seconds and is going to go a distance 50 meters horizontally. Answer choice B.
And they try and trick you with choice D, saying 50 meters to the right of B, but here, as you pointed out in your diagram shows, it lands right at B.
Perfect. Let's look at question 66 then. The sled and rider start from a location on the hill that is 10 meters lower than point A. In other words, now we get the sled and rider starting at a height of not 20, but 10 meters high. And the question asks, how does the speed of the sled and rider at point B, starting from this location, compare to the speed of the sled and rider at point B when starting from the top of the hill? So immediately, probably what happened to you when you read this question the other day is you looked at it and you said, oh my God, I have no idea. Well, I got to calculate a velocity here. Well, remember, it says in the passage that there's no friction acting upon the sled and rider as they slide down the hill. No friction means no force. In other words, we can say that all the energy that they had at the top of the hill, or if they started here, all the energy that they had there is converted into kinetic energy, in this case, at the bottom of the hill. In other words, because there's no work, no force on it, their energy will be conserved. At the top of the hill or over here, what kind of energy do they have, John?
Gravitational potential.
Gravitational potential energy. And the formula for gravitational potential energy is mgh. So they've got an mgh here, and because there's no force working on them, all that potential energy will be converted to kinetic energy at the bottom. And of course, the formula for kinetic energy is 1/2 mv squared. And knowing that these two are going to be equal for this one and then for this one individually, we can set those two equal to each other, do a little bit of simple algebra, and we get v is equal to the square root of 2gh. This formula, if we know the height an object starts at, if there's no forces acting upon it, we can calculate its velocity after it's fallen a certain height if it's being affected by g gravity. Let's plug in some numbers here. 10 is exactly half of 20. So if we're comparing the speed that this sled is going to reach at point B and beyond versus the speed that this sled is going to reach, this h is 10, this h is 20, it's twice as much. G and 2 are both going to remain constant, so what we're really looking at is a proportionality problem, where if we double the height, we want to see how that doubling of the height affects the final velocity. And we can see, again, G and 2 are going to be constants here, so we got is really V is proportional to the square root of this increase, this doubling of the height. In other words, the velocity that this sled is going to reach is going to be 1 square root of 2 times greater than the velocity this sled is going to reach. Would you agree?
I'd agree.
Let's find the answer choice that says it. Again, reading the question very carefully. How does the speed of the sled and rider at point B, starting from this location, compare to the speed of the sled and rider at point B when starting from the top of the hill? Obviously, the speed of the rider starting at this location is going to be slower than the speed of the rider who starts up top. How much slower? Slower by the square root of 2, or by a factor of the square root of 2. 66, best answer, D.
And one thing you should recognize about this question is, and the way you knew to go to energy is, whenever you look at a question, decide right away, can you use energy to solve it, as opposed to vectors. It's always easier to use energy to solve a mechanics problem than vectors when possible, because energy is a scalar. It's easier to use scalars.
Exactly. Good point.
Hi, we're back with passage 11. And what we're doing right here is we're going to set up a standing wave. So a standing wave is just going to bounce back and forth, and it's going to look like it's standing still. So let's set up, well, here's one standing wave, and then we can set up another one if I double the frequency. That's what a standing wave looks like. Notice right there we have a node. Okay, so that's passage 11. That's how we're going to approach it. We'll start with question number 67. What is the spacing between adjacent nodes in a standing wave pattern? Well, if we just draw out our wave, really between adjacent nodes, between any wave pattern, is going to be a half lambda. So answer choice there is lambda over 2 or D.
John, that's an interesting one because it relates back to the question of what is adjacent and what does adjacent mean. To me, if I see it on the MCAT, adjacent means exactly next to.
Question 68. For a given laser cavity mode, the standing wave pattern within a laser cavity can be viewed as a superposition of two traveling waves. That's one wave on top of another. Their amplitudes and directions are described by which of the following? So if we have, in a laser cavity, they're going to be moving just like our wire. They're going to move in opposite directions to each other and collide with each other, and they superimpose. So opposite directions gives us either choice A or D, and then amplitudes are going to be choice A. And why is amplitude equal?
Because you're talking about the same wave, essentially. It's just being reflected back.
Exactly. It's just the same wave bouncing back and forth, so the amplitude's not going to change. Question 69. A certain laser has only one mode of oscillation. Which of the following are properties of the light it emits? If it has one mode, we see in the passage it said mode numbers that are related to the allowed cavity wavelength. So the mode number is related to the wavelength. Wavelength, back here, C is a constant. Wavelength is related to frequency. So if we know the wavelength, we know the frequency. If we know the mode number, we know the wavelength, and we know the frequency. Remember, the frequency tells us the color of the light. So if there's one mode number, then there's one light color. That means it's monochromatic. So answer choice, we got to have 1 in the answer choice on 69. That means D is out. Now the question is it coherent? Well, I didn't study coherent when I'm studying MCAT. I didn't study about the coherence of light. It's a little too technical for me, and I'm going to look back in the passage then, because I assume it's going to be in the passage if I didn't study it. First sentence, lasers produce extremely coherent light. So it is coherent. So choice 2 has got to be in there. I'm left with only choice B. Choices 1 and 2, answer B for 69. Question 70. A gas laser has a cavity of 1/3 meters and a single oscillation frequency of 9 × 10⁻⁴ hertz. What is the cavity mode number? For here, I'm going to go to the passage and get the equation they gave us. M lambda equals 2L. So they told us M is for what, Jordan?
M is for the mode number.
And so M is the mode number. Lambda, where can we get lambda? They don't give us lambda, they give us the frequency. So where do I get it?
Well, you'd have to use that first formula there.
Exactly.
And set C over F, or the frequency, to get lambda.
Exactly. I'm going to do lambda equals C over F. So over here, they give us in the passage the value of C, which is 3 × 10⁸, but you should also know that. And then F is 9 × 10 to the, is it -14?
It is 9 × 10⁻⁴ hertz.
9 × 10⁻⁴ hertz, okay, times M. That equals 2 times L, and L is the cavity length.
Is 1/3
They gave in the question is 1/3. So we end up with M equals 2/3 times 9/3 times 10⁻⁴ over 10⁸. Okay, so we end up with 9/9 cancels. We have 2 times 10⁶. That
would be answer B.
Choice B is correct. Number 71. A gas laser can oscillate simultaneously in two adjacent cavity modes. This oscillation produces beats. The beat frequency is F equals blah, 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 blah. This kind of question just drives me nuts. They just use too many words, and they try and confuse me. Look at what they're really asking, the actual question. Which of the following is an expression for the beat wavelength? There's only one answer choice here that gives the proper units of wavelength. If I look at this equation here, wavelength has to be c over some frequency. And if we take a look at our answer choices, there's only one that gives me c over some frequency, and that's choice D. 71 is the answer. Standalones. Let's start with question 72. An object that is totally immersed in benzene, specific gravity of 0.7, is subject to a buoyant force of 5 newtons. When the same object is totally immersed in an unknown liquid, the buoyant force is 12 newtons. What is the approximate specific gravity of the unknown liquid? So if we draw a picture here, instead of going into a bunch of formulas, let's just draw some pictures. And this is the way I like to solve all these problems. We draw a picture of the object. I take that object and I submerge it into a bucket of benzene. And I'm going to displace benzene. And this volume of benzene I displace is equal to the volume of the object, right? Archimedes' principle. And they tell me that when I put that object in a bucket of benzene, there's a buoyant force, a force up of 5 newtons. What you need to know about buoyant force is that that is the weight of the fluid displaced. So this size of benzene actually weighs 5 newtons. That's what they're telling us when they say the buoyant force on the object is 5 newtons when it's placed in a bucket of benzene. Then they tell us there is this unknown fluid. And when I place the object into that unknown fluid, they tell me the buoyant force is 12 newtons, which means, of course, that an unknown fluid, the amount of unknown fluid this size, the same size as benzene or the object, is going to weigh 12 newtons. That's what buoyant force means. The force upward is the weight of the fluid displaced. All right, there's one piece of information I haven't used from the question yet, and that is the specific gravity, which is 0.7. Specific gravity of benzene is 0.7. And what that tells me is that benzene weighs 70% what water weighs. So if I take a volume of water that's the same volume as benzene, that means that what should this water weigh? It should weigh a little more than the benzene. The problem is the math. Right?
It's very difficult math.
0.7. When I get a problem with that where the numbers are bad, I'm just going to change the number just to see what would happen. What if the specific gravity of benzene were 2? That would mean benzene's twice as heavy as water. So if that were true, the same amount of water would weigh how much?
2.5 newtons.
2.5. How do we get that number? 5 divided by 2, and 2 is the specific gravity. Well, the specific gravity is not 2, it's 0.7, but we'll keep it in the same spot. 5 divided by 0.7. That's the weight of my water, 5 divided by 0.7 newtons. Okay. Now they're asking me the specific gravity of my unknown. What I have here is a comparison of the weight of this volume of water compared to the same volume of my unknown. And specific gravity, as we know, is density, the specific gravity equals the density of some fluid or object divided by the density of water. And we know that density is mass over volume. So mass of the object over volume of the object, or fluid, divided by mass of water over volume of water. This is specific gravity. These volumes are the same, right? My volume of water and my volume of my unknown are the same. So I only have to compare my masses. And what I have is the weights, which are in the same ratios. So my specific gravity then is going to be the weight here, 12, divided by 5 over 0.7. And that is 12 times 0.7 over 5. Okay? So 12 times 0. I'm going to get rid of my decimal here. 12 times 0.7 is really 7 over 10. 5 over 10. So I get 84 over 50. What's my answer choice?
1.7. C.
Something less between 1 and between 1 and 2. Answer choice C. Really tough problem. Let's just go over again. What I'm doing is understanding what the buoyant force really is. The buoyant force is the weight of the fluid displaced. And since I know that when I totally submerge an object, it displaces a volume of fluid equal to its own volume, now I know the weight of this volume of fluid because it told me buoyant force. Then I compare the buoyant forces here, and I look at the specific gravity. Remember how I got the specific gravity over here? I said if the specific gravity were 2, then I would just say this is twice as heavy as water, so I'd divide by 2. It'd be 5 over 2. It's not 2, so I get rid of the 2, and I say it's really 0.7. There's my buoyant force if this object were placed in water. Now I have this volume of water and an equal volume of an unknown, and I know their weights. And I can compare their weights because the ratio of the weights, right? Weight is mg. If I make a ratio of the weight, it's the same as the ratio of the masses. So I compare them, and I get the ratio of the masses, which gives me specific gravity. Okay. We'll actually try that again on problem 77. Right now, let's go to problem 73. A 1 kilogram object slides along a frictionless surface at an 8 meters per second until it strikes a stationary 3 kilogram block. If the block sticks together, what is their speed immediately after the collision? So this is a conservation of momentum problem, just like in the sled passage. And what we're going to do is we're going to say the initial momentum equals the final momentum. In the initial momentum, only one object is moving. So we have mass times the velocity of that object. The mass of that object was 1. The velocity was 8. Thank you, Jordan. And in the final momentum, we have 2 masses moving, but they're stuck together. So we'll add their masses together, m1 plus m2, times the velocity that we'll solve for. So m1 was 1, and m2 was 3 times v. So we end up with 8 over 4 is the final velocity. So initial momentum equals final momentum. Solve for velocity, we get 2. Answer choice is B. Number 74. Which of the following will occur if the acidity of a saturated solution of calcium hydroxide is increased? All right, we have a saturated solution of calcium hydroxide. And what formula do we use when we have this saturated solution?
KSP.
Yeah, KSP. In other words, you use calcium hydroxide plus water goes to calcium 2 plus OH minus. And you know what? I'm not going to use the water. Why?
Because there's so much of it that...
Yeah, water, it's a constant 1, right? We basically assume, even in a saturated solution, we assume that the mole fraction of water is 1. That's kind of a funny thing. We say there's so much calcium hydroxide, but we're in undergraduate chemistry, so we're saying the saturated solution has a mole fraction of water of 1, and water is a pure liquid. We don't use it.
So what you're saying, essentially, is that KSP, we never consider that water. When we calculate the KSP,
that's correct.
Dissolving salt.
That's correct. The water is a mole fraction of 1. We don't consider it pure liquid. All right, here the question asks if we add acid, what happens? If we add acid, we're adding an H+, and where is the H+ going to react?
Going to react with the hydroxide ion there.
Exactly, it's going to react with the base, the strongest base. And the strongest base here is the hydroxide ion. When it reacts with the hydroxide ion, it's going to make water, and that drops out of our reaction. And what does it do by Le Chatelier's principle?
Le Chatelier, one of our products is going to diminish. It's going to push the equilibrium in that direction.
Correct.
To the right.
Move the reaction to the right. And so our answer choice is?
The best answer choice is
B. The KSP will be unchanged and additional calcium hydroxide will dissolve.
Right.
Because
now, KSP is a constant. So
exactly. KSP doesn't change because it's a constant. All right. Question 75.
Ooh, this is a hard one.
Question 75. You want to know something about farsighted and nearsighted. This is unusual on MCAT, but sometimes I throw one in there just to try and make sure that you study more than you really should have to. Okay. In a nearsighted individual, the image of a distant object is focused. Now, and we want to know first, this is the eye, and here is the lens. The lens is a converging lens, or a convex lens, the lens of the eye. In a nearsighted person can't see things far away. And here's the way I remember it. A nearsighted person tends to focus things. They want to focus things here on the retina, right? That's where you want to focus parallel light rays. But what happens with nearsighted is they focus nearer to the lens. Farsighted focus farther away from the lens. So here, when they focus nearer to the lens, there's where it should, this focal point here should be at the retina, and it's not. We need to move it back. So what do we have to do to move it back? We put a lens over here. The kind of lens we use is going to be a diverging lens, which will diverge this outward, bringing that focal point back to the retina. So in a nearsighted individual, the image of a distant object is focused in front of the retina. That's choice A, requiring a divergent lens correction.
Oh, that wasn't so hard after all, huh?
Not too tough. You just had to know about where the focal point was for nearsighted. Remember, nearsighted near the lens, farsighted far from the lens. Question 76. The principal quantum number is a measure of which of the following?
Well, principal quantum number is just the energy level, so that would be the size as opposed to the shape or anything else.
Exactly. So choice A, approximate radial size of an electron cloud. And you're just going to have to know that for MCAT. Question 77. We're back to these balloon problems. These are tough. Again, I think this one, 77, is not quite as tough as 72. An unknown solid weighs 31.6 newtons. So let's draw our unknown solid. We'll call that our object. And its weight is 31.6. When submerged in water, its apparent weight is 19.8. So we put it into water, and the apparent weight of the object, apparent weight, that's what it feels like when it's underwater. You know, when you get into water and you feel lighter, that's your apparent weight. Why do you feel lighter?
Because the buoyant force from the water is holding you up.
Exactly, it's pushing you up. So they're really telling us what the weight of the water is here, but it's not 19.8, right? That's the weight that the object feels like it is when it's underwater. In other words, the object is 31.6 minus that 19.8, right? That's the weight of the water, the buoyant force. The weight of the buoyant force is 31.6 minus the 19.8. So 31.6 minus 19.8, so like about 11.8. Okay? And then we have, what is the specific gravity of the unknown sample? Specific gravity, remember, is the weight of the object compared to the weight of the same volume of water. And we have the weight of the object, 31.6, and the weight of that water, 11.8. So this is about, let's call it 32 over 12. 12 and 12 is 24, so it's about 2.5 roughly. And what do we end up here with? 77. The closest to 2.5 is?
B.
Choice B. And that's the physics section, and I hope you hung with us. All right, we're on the bio section of Practice Test 5R. And if we take a look at passage 1, it's fairly typical. We've got hypothesis 1 and hypothesis 2. When you read something like this, you're not trying to master the passage. You're trying to understand just kind of the basics about what they're saying. And both these two hypotheses are talking about how the immune system turns itself off, or how the immune system doesn't attack, why it doesn't attack your own cells. Hypothesis 1 says there's a mechanism as a fetus where the immune cells that would attack you are actually shut off as a fetus. Hypothesis 2 says that there are suppressor cells that actually prevent your immune cells from attacking yourself, and that's how they shut it off. So these are the two different hypotheses. Let's go to the first question, 138. Certain individuals with autoimmune thyroid disease have an increased susceptibility to autoimmune liver disease. According to hypothesis 2, which of the following groups of effector or suppressor cells have most likely been lost or inactivated in these individuals? Now, before I go to the passage or think too much about the question, I'm going to read the answer choices so I make sure I don't do too much thinking and spend too much time. A, suppressor cells that respond to thyroid cells, but not those that respond to liver cells. So right away I see that they're making a choice. Is it ones that respond to liver and not thyroid, or thyroid and not liver, or both? And I know what I'm looking for. I want cells that respond to both. So I know A is going to be wrong, and I know that from the question. Choice B, suppressor cells that respond to both thyroid cells and liver cells. Yeah, because they react with both thyroid and liver. So it looks like B is correct. Now, do they give me a possibility of effector cells that respond? Yeah, and choice D, effector cells that respond to both thyroid cells and liver cells. So do I want effector or suppressor cells? I look at the question again, and it says, Which of the following groups of effector or suppressor cells have most likely been lost or inactivated in these individuals? It's when certain individuals with autoimmune thyroid disease have increased susceptibility to autoimmune liver disease. So apparently the suppressor cells are not doing their job. They're not suppressing the other immune cells. So choice B is the best answer. Question 139. The human body never develops self-tolerance to the proteins of the cornea. According to hypothesis 1, one reason for this might be that the corneal proteins, this is a reading comp question. From the hypothesis 1, that's what the question refers you to, we see that circulating lymphocytes remain inactive until they encounter their specific antigens. And here we see choice A is the best explanation. They never circulate in the body fluids. Therefore, they are never exposed to lymphocytes, or those circulating lymphocytes. So they're never deactivated. So choice A for question 139. Question 140. According to the normal mechanism of self-tolerance described in the passage, the body will respond to each antigen it encounters by activating. If we take a look here, again in hypothesis 1, they tell us identical groups, clones, of circulating lymphocytes remain inactive until they encounter their specific antigens, after which they proliferate. So choice D, a clone of lymphocytes specific for that antigen. So according to the normal mechanism of self-tolerance described in the passage, the body will respond to each antigen it encounters by activating a clone of lymphocytes specific for that antigen. That's reading comp from the second paragraph.
That's a difficult set because even though it is reading comprehension, so much text and so dense, it tends to be confusing. And so if you got caught up on it, probably what happened there was you got overwhelmed with the amount of words that they used.
Right. Jordan, why don't you take 141?
Thanks, John, I will. 141 reads, according to hypothesis 2, the normal balance between effector and suppressor cells specific for a certain tissue will most likely be disturbed if the tissue is injected with. You really have to ask yourself, well, what is normal balance? And what would disturb normal balance? Well, what would disturb normal balance is if you put something in there that somehow reacted and disrupted the normal balance. So let's find the answer choice that says that. I'm looking at C and D because now we're introducing something foreign into the body. And of the two, I'm looking at C because C says a foreign substance that cross-reacts with cells of that tissue. In other words, how do you disrupt normal balance? You put something in there that's foreign that cross-reacts. Now, what does cross-reacts mean? It just means reacts. It means somehow it disrupts the system.
Right, good. I like the way you keep it simple. Who cares what cross-reacts mean? It just kind of means what it says, it reacts. All right, let's go to question 142. Does acceptance of the mechanism of self-tolerance described in hypothesis 1 rule out acceptance of the mechanism described in hypothesis 2?
Yeah, this is an interesting question because I think most students get trapped into, well, they're presenting two hypotheses, 1 and 2, so one of the two must be right. And I think a lot of students fall into the trap of saying, well, yeah, if one is true, then the other must not be true.
Right.
That would be a bad assumption.
It would be a bad assumption. I think in this case especially you have to realize that both hypotheses 1 and 2 are true. You should actually have that from MCAT knowledge. It would be in our books. So the answer is no. It does not rule out the acceptance of hypothesis 2 because they actually are, that is actually the way it works. So we're driven to choice C and D. In choice C it says no because suppressor T cell formation can only occur after clonal deletion has occurred.
And that just doesn't make any sense. I mean, it just doesn't make any sense.
And choice D then is what we're left with. Clones of self-reactive lymphocytes not destroyed by clonal deletion may be controlled by suppressor T cells. That makes sense. If they're not destroyed when hypothesis 1 is activating in the fetus, then when they go to the hypothesis 2, they have suppressor cells that can actually suppress them. So answer choice D for number 142. Question 143. The mechanism of self-tolerance described in hypothesis 1 is generated in which of the following regions of the body? This is just MCAT knowledge. You want to know where the initial immune cells are created, and they're created from in the bone marrow from the stem cells, the precursor stem cells. So answer choice A, bone marrow and thymus.
And that's just because the T cells mature in the thymus, so that's what's going on there.
T is for thymus, and B is for
bone marrow.
No, remember from osmosis? Bursis of Fabricius. So it's not for bone marrow, although it's probably reasonable to think of it that way, that the B cells actually mature in the bone marrow and the T cells mature in the thymus. So choice A there for 143. what exactly are you doing?
I'm trying to isolate this alcohol from these termites. I figure we'll bottle it, sell it, make $1 million.
Aren't those ants?
No wonder this stuff tastes so bad. I guess we better work on the next passage, huh?
I guess so.
All right, we're looking at passage 2, starting with question 144. And question 144 reads, compound Y is shown below. Based on scheme A, compound Y can most likely be synthesized by substituting. We've got a couple of graphs here, right, for this one?
Yeah.
Let's look at it. First, we've got a graph of scheme A. And if you would, this outside one here is compound Y,
Compound Y.
right? So what we've got here, and the question is, how can we synthesize compound Y, given scheme A? And if we look at scheme A, compound Y looks awfully similar to something called compound 4 down here at the bottom. In fact, the only substantial difference is that we've got an additional methyl group on compound Y. So if we wanted to synthesize compound Y, it makes sense that we'd go through a similar set of reactions that we did to get compound 4. If we move back up a little bit, we can see that in order to get this CH3 group here on compound 4, we replaced a carbonyl group with this CH3 group. How did we do that? We reacted this carbonyl with CH3 MgBr.
Grignard reagent.
In a Grignard reaction. Good. Let's see how we could do it. What could we substitute? Which one of these answer choices could we substitute? If we look at choice D, the only difference in choice D is that the Grignard reagent we're using has the ethyl group in place of the methyl group that we used to react and form compound 3 and then compound 4. So D is the best answer. We'll add that extra alkyl or methyl group by reacting with a different reagent.
And D says step 2, anyway, which is the step we're trying to replace.
That's exactly the step. So best answer for 144 is D. 145 says, why did the chemist convert the C8 carbonyl group in compound 1 to a ketal group in step 1? So maybe we better look at this one. This one kind of sounds like, why did the chemist cross the road?
That's what I was thinking.
To get to the other side, of course. Chemists are pretty smart that way, you know what I'm saying? So it says, why did the chemist convert the C8 group in compound 1 to a ketal? And so what's going on, here's the C8 group in compound 1, and what happens is in the first step of this multi-step reaction, the chemist converts it to something that looks like this. Why did he do that? Well, he did it because he didn't want this group here to react similar to this group, right? This is a carbonyl just like this carbonyl, and if he didn't protect it in some way, it would have reacted just like it did here in step 2, and we would or in step 4 also, we would have replaced the carbonyl group. So we wanted to protect it. Let's find the answer choice that says it.
And we see that because when we get down to here in step 7, we put it back.
Oh, beautiful.
And this is right from the book. Yeah, these are blocking groups. Ketal groups are blocking groups.
Great. What's the answer choice that agrees with that? That would be C. The C8 carbonyl group must be protected to prevent it from reacting in steps 2 and in step 4. Pretty simple. Answer choice C for 145. 146 is some must-memorize information. If you haven't done it already, you must know that in infrared spectrum of compound 4, you've got, not that you have to memorize the infrared spectrum of compound 4, but whenever you have stretching at 3300, that indicates the presence of what kind of functional group, John?
That's the alcohol.
This is an alcohol or a hydroxyl group. So anytime you have IR spectrum stretching in the neighborhood of 3300.
And it's a broad stretch.
Good. And I just memorized high. If it's really high, above 3,000, I mean, think about if your blood alcohol content was that high, you'd definitely be really drunk. 3,300 indicates an alcohol. Another one that they want us to memorize on MCAT, and they've done this by asking this question a couple times, is a stretching at 1,700 indicates a carbonyl group. And so I've got a stupid little mnemonic, if you'll forgive me. If you draw the 17 this way, it kind of looks like a double bond to oxygen. It's a carbonyl group. So stretching at 1,700 in the IR spectrum, carbonyl. Stretching at 3,300, alcohol. Question 147. In step 6 of scheme A, if H2O is replaced with deuterium-2O, what will be the structure of the product? And if we look in, again, scheme A, we look at step 6 here, we've got an epoxide ring, and we're adding, across it, we're adding H2O, and we're forming a CH3 group and a hydroxyl group. Now, this is a little bit of read and understand the diagram, and add to it, read and understand the passage. Last paragraph says, when compound 6 is treated with lithium aluminum hydride, the hydride attacks an epoxide carbon. In here, the epoxide carbon is obviously this thing, just the corner in this ring, meaning this CH3 group is not going to have a deuterium on it, it's going to be a CH3, because that H is coming from the lithium aluminum hydride. the last paragraph goes on to say the ring opens and the resulting oxygen anion is subsequently protonated with water. Well, if we took the water out and we put deuterium in, that means we replace this hydrogen right here with a deuterium atom. Let's find the answer choice that agrees with that. Obviously, we've got the CH3 protonated by the hydride in lithium aluminum hydride, and we've got the deuterium replacing the hydrogen here. That looks like my best answer choice. This one's wrong, and this one has a deuterium on both the carbon and on the oxygen. This one's wrong. A is the best answer for 147.
Okay, we're on passage 3 in biology. And if we take a look at passage 3, there are two diagrams. We have two different modes here. First, we're adding acetylcholine esterase inhibitor. That's drug X. And acetylcholine is what, Jordan?
It's a neurotransmitter.
Yeah, so it transfers a signal from one neuron to the next or neuron to the muscle, right? So here when we add an acetylcholine esterase inhibitor, acetylcholine esterase is the enzyme that breaks down acetylcholine within the synaptic cleft. If we add an inhibitor, so this is not broken down, what's going to happen?
Well, the signal would continue to be transmitted.
Exactly. It's like more acetylcholine. If we look at drug Y, then they tell us it's a blocker of the postsynaptic acetylcholine receptors. Now here, this little square represents a blocker of the receptor. You've got receptors on this neuron or muscle, and these receptors receive acetylcholine. If we block that, the acetylcholine can't get to its postsynaptic neuron or muscle. So we block the signal. So it seems like drug X, at least initially, is increasing the signal by not having the acetylcholine destroyed, and drug Y is blocking the signal by blocking the receptors. Let's just take a look at the diagrams here. And if we take a look at drug X, notice here on the Y-axis, number of trials until 100% avoidance. Now what they're trying to avoid is pain, right? So we expect the smart rats are going to do a large number of trials or a few number of trials.
They do very few, the smart ones.
Smart rats try to avoid pain. So when we add drug X, what happens to the number of trials?
Goes down.
Fewer trials, so they're getting smarter. If we add too much X, look what happens. Trials go back up. And so they're not as smart as they were. So initially, drug X seems to make them smarter, and then they're not so smart. And that kind of goes with what we said drug X does. It allows more of the signal to get across. If we take a look at the diagram for drug Y, number of errors. Number of errors. Errors is a bad thing. So when we add drug Y, they seem to be getting more errors. They seem to be getting a little dumber. Yeah. Okay. Question 148. ACH is the transmitter in the striated voluntary muscular system. What effect would drug Y have on the function of this system? Well, drug Y would block muscular contraction because it blocks the signal. So answer choice C.
That was easy.
Easy enough, once you understand the passage.
Sure.
Number 149. An underlying assumption of the researcher regarding the actions of drug X was that it increased the amount of ACH in the synapse. So this was the point of drug X, was to increase the signal, and the researcher reasoned that if we had less acetylcholine esterase, which does what again?
It's going to break down acetylcholine.
Exactly. If it breaks down acetylcholine, if we have less stuff breaking it down, we're going to have more acetylcholine. So answer choice
A. And that's an assumption because it's not stated directly.
Exactly. Okay. Number 150. If drug X and drug Y are given together, will the rate of learning most likely increase or decrease? Now really what we're doing is adding these two diagrams together. And what we have to look at, and we're also going to do a little reasoning here, if drug X again is blocking these receptors, drug Y is blocking the receptors, drug X is basically not preventing the breakdown of acetylcholine. So if we put those two things together, even though we have more acetylcholine, there's nothing it can do because the receptors are blocked. So we would expect the rats to get dumber or smarter?
Dumber.
Dumber, right, because less signal is getting through. So answer choice for 150 is D. The rate of learning would most likely decrease, choice D, because although drug X will increase ACH production, drug Y will prevent it from being taken up by postsynaptic receptors. Let's go to question 151. the researcher discovered that increasing the concentration of drug X resulted in greater inhibition of the hydrolysis of ACH by acetylcholinesterase. However, this effect was counteracted by increasing the concentration of acetylcholine. These results indicate that drug X acts on acetylcholinesterase as, and here, this is just a classic symptom of a competitive inhibitor. You can overcome a competitive inhibitor by increasing concentration. Because what happens is, in a competitive inhibitor, you have, here's the enzyme, and here is my, we'll call this my inhibitor, and we'll call this my protein that the enzyme is acting on. And here would be the active site. So the inhibitor and the protein compete for this active site in a competitive inhibitor. That's why it's called competitive inhibition. They bind for a fraction of a second and then are released. So if you have one I and one P, you got a 50-50 chance at any time that you're going to have either one attached to the active site. But what if I overcome my competitive inhibitor with a lot of P's? Now I have 9 P's up here, 2, 4, 6, 8, 9 P's up here, and 1 I, and now what's likely to happen?
It's much more likely that the enzyme is going to bind to P.
Exactly. 90% of the time I expect P to be there, and the enzyme is actually going to be working, and I've overcome my competitive inhibitor.
Wow. So that's a really easy problem when you break it down that way, but when you look at it, there's so much text, and it seems like there are double negatives going on in there.
Exactly. In MCAT, you're looking for the simplicity. You're looking for the simple answer. What is this simple question they're asking you? And here they're just asking you, do you recognize the classic symptom of a competitive inhibitor, that it can be overcome by substrate concentration? 152. Based on the experiment in the passage, the best overall description of the effect of ACH on rat learning and memory is that, now we really already covered this, moderate increase in ACH utilization appear to improve memory and learning. And what that was when we had drug X, which remember increased ACH, right? It effectively increased ACH. Drug X then made the rats smarter in a moderate amount. If we put too much drug X, it made them dumber, actually. So answer choice here is B, moderate increases. 153. The fastest way to counteract the effects of drug Y would most likely be to. Now remember, drug Y is blocking the receptor here. So the fastest way to counteract the effect of drug Y would be to increase its rate of metabolism and elimination from the body. We're going to have to remove that because drug Y is not a competitive inhibitor. We're not going to be able to overcome it with substrate concentration. 154. An autosomal recessive non-lethal mutation of the ACH receptor gene occurs in some rats. Which of the following organelles will most likely be abnormal in the rats having this mutation? This question is simply asking you, do you know where these receptors are located, the ACH receptors? And they're located on the membrane of the postsynaptic neuron or muscle. So answer choice there would be D, plasma membrane.
Best answer.
Best answer.
Wow! Look at that!
Well, what's so interesting?
I'm not sure, but I think it's pornography.
It's not pornography. That's a mating cycle of tetrahymena.
Well, it's still tetrahymena having sex, isn't it?
That's an MCAT passage, Jordan. You like that so much, why don't you do that one?
Okay, I will. When you read this passage, you probably thought, whoa, what are they talking about? And believe me, that was completely and intentionally by design. You were supposed to read through this passage and not have a clear idea of what you were doing when you got to the questions. But if we turn over and we look at the questions, what's interesting about the questions, especially if you have a passage which is completely intimidating, is that the questions oftentimes are very easy to handle or are not terribly difficult to handle. Let's start with question 155. 155 says, sexual reproduction is advantageous to tetrahymena primarily because sexual reproduction is, well, when I think about sexual reproduction, I think an advantage of sexual reproduction is, well, frankly, that it's fun. But in biology, the advantage to sexual reproduction is what, John?
Well, sexual reproduction increases genetic variability.
Genetic variability, whether it's happening in humans or tetrahymena or, termites.
That's the whole point of meiosis.
Bam, let's find the answer choice that says, oh my God, look at question 155. A says increases genetic variability in the population. That's the purpose of sex on a biological scale. 155, best answer is A. 156 says, in the macronucleus, the genes for rRNA are located extra-chromosomally. This suggests that rRNA genes are. Well, if they're extra-chromosomally, are they inside the chromosome or outside?
They must be outside the chromosome.
So if they're outside the chromosome, then they're probably not going to replicate when the chromosome replicates, right?
And if they don't replicate when the chromosome replicates, that must mean they're self-replicating.
Let's find the answer that says that. Oh, C. 156 is C. And you can see how if we take each question on its own merits, instead of being intimidated and confused by the passage, sometimes these questions are a little easier. Let's look at 157, see if we can keep this up. An extra S phase occurs during amitotic division in a small macronucleus to minimize fluctuations in DNA content. This is most likely triggered by the presence of, if we look at the cell life cycle, we've got a pie chart. A small wedge here indicates mitosis. We've got two growth phases, here and here, and then we've got S, the synthesis phase. And what happens during synthesis is replication. And the function here is, remember, in the cell life cycle, in the end of the cell life cycle, we're going to do mitosis. We're going to split. We have this synthesis phase to make more DNA, because that's what replication is. Well, the question is, why would you do that if you didn't have what?
Well, I think the best answer choice there would be low concentrations of DNA. If you didn't have enough DNA, you'd want to do an extra S phase. It's the only answer that makes sense there.
Great. So 157 is A. You don't have enough DNA, you got to make more. 158. The macronuclei of the asexual progeny in tetrahymena. Oh my God, I have no idea anything about these. Because I didn't read, and I mean, I did read, but I don't really understand what happened in passage 4, potentially. But then it says, and the cytoplasm of the ova-producing cells in female vertebrates share a common feature in that both. Now, I think you don't have to know too much about tetrahymena. You do need to know that the ova-producing cells in female vertebrates, what happens is you form 4 gametes. One is called an ova, and the other 3 are called polar bodies. And the difference between the ova and the polar bodies is the ova gets cytoplasm, and these 3 polar bodies don't. Let's find the answer choice that says it. A says, undergo uneven division. Well, you got one ova with a lot of cytoplasm, and these other 3 went through these both meiotic divisions, but didn't get as much cytoplasm. Uneven division, by definition. Best answer for 158, A.
So what you essentially did for 158 is you saw that it needed to be true for both tetrahymena and for ova-producing females, human females, or actually vertebrate females. You knew about vertebrate females, so we went down the line to make sure what is true about vertebrate females. It turns out that only A is, so we didn't even have to know anything about tetrahymena.
Exactly, and if I had been intimidated and confused by the passage, I wouldn't even have read probably the second part of that question.
You would have been looking through that passage for that answer forever.
Spending time and losing points.
Exactly, so don't be intimidated by the MCAT, because that's what they're trying to do.
159. When an initially heterozygous macronucleus undergoes repeated binary fission, the result will be. Now, they're really not defining what repeated binary fission is, but you got to know it's happening a lot of times. And binary fission means you start with one cell and it's constantly divided. Well, one thing that you can understand from the passage, interestingly, the last paragraph of the passage is the only one that is really what I'd call comprehensible on some level. If you look in that last paragraph, it says that each daughter cell receives an exact copy of the micronuclear DNA and an uneven but approximately equal amount of DNA from the amitotic macronucleus. To minimize fluctuations in DNA content, small macronuclei undergo an additional S phase before division, and large macronuclei eliminate an S phase. Going back to question 159 then.
It's the uneven part that we're looking at.
Exactly.
Okay.
So what we're looking at is when an initially heterozygous macronucleus undergoes repeated binary fission, well, it says in that last paragraph that we're going to have uneven. We want to minimize the fluctuations, but it's not going to be the same. What's the best answer? The best answer is D. It says a variable allele distribution, in other words, very distributed or variably distributed genes there in the macronucleus. Let's look at question 160. It reads, some of the DNA sequences that are eliminated during macronuclear differentiation may be sequences involved in. It says in the passage, in the first paragraph, that macronucleus is the site of gene expression. Gene expression, the way we represent or express genes, is by the production of proteins. So the one here that is not represented by gene expression is C, meiosis, which happens when we divide cells.
So the whole point of that question was just realizing macronuclei are involved in gene expression. And so And that's it. And you get answer choice C.
Question 161. In a mating of two tetrahymena strands that are homozygous in their macronuclei and heterozygous in their micronuclei for a recessive gene, what percentage of the F1 generation will express the recessive phenotype?
Oh my gosh, you mean I'm going to have to go through this thing and figure this out now to answer that question?
Exactly. Put yourself in the frame of mind you were in yesterday when you got through this very difficult to read passage, and now you get to this very difficult to understand question. MCAT understands where you're at this point, and this question is designed to make you go looking around for what is the right answer. In my mind, and I think in John's mind too, the right answer here is simplify it. In other words, what happens in human beings? And all we then have is a Punnett square. We've got a regular cross. In the F1 generation in human beings, you've got the disease and then the recessive disease. The disease gene and then the recessive disease gene. The dominant and the recessive gene. The cross here, the only ones that will be homozygous for either the recessive or even the dominant allele here will be phenotypically 25% of the population. We got 50% will be heterozygotes and 25% will be the opposite homozygote.
So this question actually becomes very simple. And the idea is don't spend all day on this question because unless you're finishing the bio very early, you want to just make the assumption that this is the MCAT, it's testing basic science, and you want to go for the basics. Put it in what everybody's going to know. It's not asking a question that most people don't know the science. It's asking a question that concerns science that most people know. So as Jordan did, put it in the basic science.
General bio. So let's look at the first set of freestanding questions in the bio section, questions 162 to 165. Starting with question 162, it asks, which of the following properties is associated with the existence of glycine as a dipolar ion in aqueous solution? One of the things you should understand, when you see glycine, or any amino acid for that matter, it is going to exist at a neutral pH as a dipolar or a Zwitter ion. In other words, it's going to have a positive charge on one end of the ion, molecule, and a negative charge on the other end, dipolar ion. What characteristic would we associate with this? This molecule would have, because we've got a positive and a negative charge on either side, would have a high dipole moment.
And it exists that way at its isoelectric point, not a neutral pH, but the pH of its isoelectric point.
Thank you. Great. Question 163. It says the compound shown above is the beta derivative of D-glucuronic acid. The alpha glucuride differs in configuration from the beta derivative at. Essentially, when you see a 6-carbon sugar, which is what we're looking at here, look at the first carbon here in the ring. The position of the O in this ring structure determines whether you've got the alpha or the beta anomer. In this case, because the OR is pointing upwards, we've got the beta derivative. If we're looking for the alpha derivative, the OR group would point downwards, again, at the first carbon.
So the answer then is C, carbon number 1, because we start numbering the carbons at the anomeric carbon, which is right next to the ring oxygen. 1, 2, 3, and number clockwise.
Best answer, A. Question 164. Suppose that the amino acid sequences of a protein, such as cytochrome oxidase, are compared for a large number of species. The greatest number of amino acid differences will most likely be found between members of different. All we got to do is we got to know our classification system. King Philip came over for good soup. And the broadest of those would be phyla. Answer choice A.
And King Philip came over for good soup is king and phylum, class, order, family, genus, species.
Thanks. 165. Which of the following recombinant processes depends on the F factor plasmid? This is must-know science information. You should know conjugation. In conjugation, the F factor plasmid crosses over through the sex pilus.
Passage 5 is an organic chemistry passage, hence the lab coats. Did you bring my rubber gloves, Jordan?
No rubber gloves, John. But I do have a rubber chicken.
I don't think that's going to work for me. Question 166. What is the pHi for the allyl bromide if it reacts with the N-methyl, oh my goodness, that's a long word, pKa blah, blah, at a maximum pH of 12.2 to give N another long word. They really like to throw those long words at you. But what's important in this question in 166? They give me the they want to know what the pHi is. They give me the pKa, 11.79, and they give me the pH, the maximum pH, 12.2. And in the passage, they give me a formula. pH max equals 1/2 pHi plus pKa. And that's basically saying the pH max is an average of the pHi and the pKa, if you notice that. So we plug in the formula, and we end up with D, 12.6. I don't think I need to do the math on that one.
No, that one's pretty straightforward.
167. The compound formed by replacing the oxygen atom between the two carbonyl groups in the acetic anhydride with NH group is classified as, now if we take a look at the acetic anhydride, this acetic anhydride is this molecule right here. If we take that oxygen and we replace it with an NH group, what do we have? The first guess, you might look at it and say, oh, that's an amide, because an amide is a carbonyl with the amine. MCAT's not going to do that because we have another carbonyl attached. If this was a carbon or something else, if this was just an alkyl group, we would have an amide. But we don't. It is a carbonyl. So we know amide is wrong. The enamine. The ene stands for alkene and the amine for an amine. We have the amine but not the alkene. Remember, if this is an NH group here. So that's got to be wrong. And the last thing is an imine, which is simply a tautomer. If you remember from the book, an imine is a tautomer of an enamine. What's a tautomer again, Jordan?
It's something that switches back and forth.
Exactly, when a proton jumps from one spot to another. And so if it's a tautomer, then it's not. Then it could change to the enamine. So it can't be the imine either. So we're left with the imide. Should you know what an imide is for the MCAT? I gotta say no. I don't think. I think what you can do is narrow down your choices here to B and choose answer B because you know it's not A, C, and D. I think this is one of those questions MCAT asks you which is outside the realm of what you really have to know. And they do this on purpose. They want to widen the amount that you study. They want to make you take more time to study. So what you end up, and this is one of Jordan's favorite diagrams, you end up doing, MCAT tests all this information, but 99% of the questions are going to be in that area. And then they're going to take one question on the physics and one question on the bio, and it's going to be somewhere out here. So if you try and get that one question right, what's going to happen?
You're going to hurt your chances on the 99.
Miss a lot of the 99 questions. And is this one question worth more than the 99 over here?
No, the 99.
Not a chance, right? So focus right here, and this is the way to get your 15 on your MCAT science section.
So you've drawn two circles there. The outer circle represents all the science that could be on the MCAT, and that 99% is kind of like a bullseye. It's the 99% that you've got a great likelihood of seeing. Just so we understand, you've got two circles representing science.
That's correct.
Excellent.
Question 168. Equation 3 can be reversed by. If we take a look at equation 3 here, we look at the reactants and the products. First of all, where's the higher energy level, the reactants or the products?
On the reactant side.
Because OH minus is more reactive than H2O. And I know that because if I stick my hand in a bottle of water, nothing happens. If I stick it in a bottle of OH minus, it's gone, right? So this is higher energy. That means if I add heat, which way does Le Chatelier's principle push this?
You add heat, it's going to push it towards the reactants.
Exactly. It's going to push it towards the higher energy level. But there's one problem here. I cannot, what's happening here, for this reactant to make this product, if the reaction is running this way, this reactant is going to come in, that O would come in and attack, as a nucleophile, this carbonyl. Carbonyls like to be attacked. And we would end up with the anhydride here. But the problem is, the O minus would have to be the leaving group. Now, that would make it O2 minus. Is that a stable leaving group?
No, it's a terrible.
It's a terrible leaving group. So what do we have to do to make it stable?
Well, we've got to protonate it.
Yeah, exactly. So we're going to, and when we protonate something, we're adding a proton, which means we use what to add a proton?
Acid.
Yeah, acids add protons. So we need to acidify it. Now, unfortunately, they give us CND, heating followed by acidification, or acidification followed by heating. Let's figure this out. If I heat it, let it cool down, then I add the proton. Do I get the reaction?
No, you wouldn't.
Because in order to get the reaction, I need to do what?
You need to protonate first.
I need to protonate. Protonate, now add the heat, and I get this reverse reaction. Answer choice D. Question 169. The first step in the mechanism of the reaction shown in equation 1 is the, now if we look at equation 1, we've got the anhydride, and then we have the amine, which is the R group and the NH2. Now remember, when we have an amine, always remember when you have a nitrogen, if it only makes 3 bonds, you've got a lone pair of electrons here. And that lone pair of electrons is usually the way the amine reacts. It's donating that pair of electrons, which makes it a Lewis base. Now, where would it donate this pair of electrons? Oxygen's got 2 pair of electrons here. So the electrons are negative. It's looking for a positive charge. Where can we find a kind of a positive charge there?
Either of the carbonyls.
Yeah, we've got a partial positive charge at either carbonyl. So it's going to attack one of those. And when it does, we end up with a leaving group here. So if we take a look at choice C, attack at the carbonyl carbon atom by the lone pair of electrons on nitrogen atom of the amino group. This is just you understanding functional group, how an amine behaves. It behaves by using its lone pair of electrons to attack something, and how a carbonyl behaves. It loves to be attacked by a nucleophile. Question 170. Aniline and benzylamine are both. If we take a look at our chart here, which they give us, table 1, we see we have aniline and benzylamine. What are our choices? Primary amines. Primary amines?
They are, because each N is bound to only 1 carbon.
1 carbon and 2 hydrogens. That makes them primary amines. That's a very simple concept. They're definitely primary amines. Let's just look at the rest of the answer choices. Are they secondary amines?
No, because they're only bound to 1 carbon.
Yeah, of course not. Not if they're primary amines. They're not secondary. Are they aromatic amines?
I'm guessing no, because they are primary amines.
Right, but now this is a tough concept, because you look at it and say, well, they're aromatic and they are amines. Maybe this is a trick question. MCAT doesn't have trick questions. What do we do when we're trying to figure out we have 2 good choices for an MCAT? How do we make that choice? What we do is we think of the simple science. Do you know for sure, if you looked around the room at everybody in the room and you say, how many people know what a primary amine is? Everybody taking that MCAT better know what a primary amine is. Now, how many people in your class know what an aromatic amine is?
Not as many.
How many can stand up and say for sure, are these aromatic or not? Not too many, right? So the answer then is the easy answer on the MCAT. What is the primary amine? Answer choice A. They're definitely primary amines, and apparently they're not aromatic amines. And of course, they're not non-aromatic amines either. So answer choice A for 170. Back to the lab.
All right, so we're working on passage 6 in biology, test 5R. And I thought I'd start out by doing a little running, getting myself going pretty good. What do you think? How am I doing?
You're doing fine there.
Let's start this passage with a little primer on the cardiovascular system. If we look at the heart, we got the left side of the heart and the right side of the heart. The left atrium pushes blood into the left ventricle, which then pushes oxygenated blood through the aorta into the systemic circulation where all the perfusion of cells takes place. That blood becomes deoxygenated in that process, returns back into the heart via the vena cava. You've got the inferior and the superior vena cava into the right atrium, where it is then pushed into the right ventricle, now deoxygenated through the pulmonary aorta into the lung to be oxygenated, and then returns to the heart oxygenated now into the left atrium. So you must know that, and I'm going to figure for the rest of the questions here, or for all the questions here, you do know that information. Let's look at 171. It says pulmonary arterial blood differs from aortic blood. Pulmonary arterial blood is coming out of the heart from the right ventricle. John, is there enough oxygen in this blood or no?
It's low oxygenated.
Low oxygen and high what?
And high CO2, because it picked up CO2 from the system.
Awesome. So it's going to the lung to off-gas CO2 and bring in more oxygen. Let's find the answer choice. Pulmonary arterial blood differs from aortic blood because it has less O2, more CO2, and lower pH. And I'm sure we'll get a chance to see how pH and CO2 affect each other. For right now, you should understand that the more CO2 you have, the more acidic the blood, so the lower the pH. Question 172 says contraction of the diaphragm. I happen to have our low-cost x-ray of what's going on within my lung cavity. You should understand that the diaphragm is a piece of muscle that runs at the base of my thoracic cavity. And what happens is when I contract that muscle, remember, muscles can only get shorter. They can never get longer. They can get shorter. So it's a dome-shaped muscle that essentially follows the base of my lungs like that. When it contracts and gets shorter, essentially it opens up or increases the space within my lung cavity. Let's find the answer choice that says that. Contraction of the diaphragm creates a, so they're putting it in a slightly different format. The question is more negative or more positive intrapleural pressure. In the middle of the paragraph, it says intrapleural pressure is the pressure of fluid surrounding each lung. So what happens is when the diaphragm contracts, the thoracic space gets larger, diminishing the pressure within the intrapleural space. And so let's find the answer choice that says that. We've got a more negative IPP, and obviously when the diaphragm contracts, I inspire, or I bring air into my body. What do you think?
I think that's correct.
Good.
And you could use PV equals nRT for that, right? As volume increases, pressure decreases.
That's a real good one, sure. So 172 is A. 173, now this is a little bit of a trick question if you look at how exactly they phrase this question. It says air flows out of the lungs. Obviously when my diaphragm contracted, the space here got larger, the pressure went down, right? So air is going to flow out when the pressure inside the lung gets larger than atmospheric pressure. So that's the answer choice that we're looking for, is when internal pressure in my lungs is larger than atmospheric pressure. And the trick here, the trap, is P sub A. According to the passage, first paragraph, P sub A is not atmospheric pressure, as you might assume if you didn't read carefully. Instead, P sub A is alveolar pressure. And alveolar pressure refers to the pressure within my lung. So I'm going to expire or breathe air out when P sub A is greater than P, which we'll call atmospheric pressure. Answer choice B is correct for 173.
Very good.
All right. 174, in comparison to the wall of the right ventricle of the heart, the left ventricle. Let's again go back to our primer. All the right ventricle has to do is pump blood through the pulmonary system or through the lung. Not very much pumping necessary when you compare it to what the aorta has to send. My diagram's a little bit off here, or it might be a little bit misleading, because the aorta has to pump to the lower extremities and to the upper extremities. I might say that I don't get the full blood perfusion in my brain, but believe me, it's happening. There's blood being pumped upwards and downwards. So this left ventricle has to do a whole lot more pumping than the right ventricle. It makes sense that the muscular wall here is larger in the left ventricle than it is in the right ventricle. Let's find the answer choice that says it. That would be C. The left ventricular wall is thicker and generates a higher pressure when it contracts. 175. If an artery that supplies blood to a lung lobe was blocked, but ventilation to the lobe was unaffected, how would alveolar gas partial pressures change? So what we're trying to determine is how the amount of gas in the alveoli changes if we block not the passage of air, but the passage of blood. So we've got a blockage in an artery. In other words, there's no blood flowing, no blood coming in. We're still breathing. We're breathing. Each time we breathe in, we bring a lot of what in, John?
Oxygen.
We bring a lot of oxygen. So alveolar partial pressure of oxygen is going to increase. It has nothing to do, the fact that there's no blood coming in and taking the oxygen out is going to help to increase that alveolar PO2. So let's find the answer choice that agrees with what we're saying. C says PO2, the partial pressure of O2 within the alveolar increase, and the PCO2 would decrease. And that makes sense because as we exhale, again, there's no new CO2 coming into the lung. As we exhale, we're still off-gassing that CO2. We're bringing new O2 in. The partial pressure of oxygen goes up, and the partial pressure of CO2 goes down within the alveoli.
Passage 7 is about invertebrates. Let's just do these questions fast. These are nice and straightforward. 176. Dissection of a crayfish reveals the presence of a hepatopancreas. Which system below would one expect this organ to be a vital component? Hepatopancreas. Hepato is liver and pancreas is the pancreas. You should know that both of these organs in a human are involved in digestion. So answer choice D, digestive system. Jordan?
All right. Question 177 reads, which of the following would be observed upon dissection of a freshly sedated insect? It says in the last paragraph that insects don't have lungs. It also says that they have an exoskeleton, not an endoskeleton. It also says in the last sentence that they have hundreds of thread-like Malpighian tubules that collect waste fluids. In other words, function as a kidney. I guess the moral of that is if you have a Malpighian tubule, you don't need a kidney. In other words, the only thing that they don't have specifically in the passage is is a closed circulatory system. They have an open circulatory system. And part of an open circulatory system would be blood-filled sinuses that would be where the blood would collect as it was passed through back into the heart.
Is that Malpighian tubules or Malpighian? Number 178. The Malpighian tubules of insects are analogous to the mammalian. The mammalian, could this be bladder, colon, kidney, or liver? If we take a look then, what do the Malpighian tubules do? They collect waste fluid and then deposit them in the posterior intestine. So bladders collect waste fluid. That could be the answer. Colon collects waste fluid. That could be the answer. Kidney collects waste fluid. And liver does not. So liver's out. But then they deposit them somewhere else. Bladder doesn't deposit them anywhere. It collects them for final voiding. Same with colon. So the only good answer there is kidney. They collect them, process them, and deposit them into the bladder. Choice C.
Good enough. 179. One would expect that the development of striated muscle in arthropods was paramount to this group's success because such tissue would allow for. One thing you need to understand about striated muscle is it does one of two things. It's either skeletal muscle, in other words, helps you move, or it's cardiac muscle, meaning it helps your heartbeat. Now, it makes sense to me, anyway, that if they had to develop striated cardiac muscle, well, they couldn't have come from anywhere because they must have had that cardiac musculature. So this new striated muscle must be about skeletal muscle. It must be about helping them move. I was going to slip in here a joke about Arnold Schwarzenegger bug, but I guess I just did. Best answer, 179A.
Also on 179, let me just point out that if you picked pumping circulatory system because the heart is striated muscle, remember the insects have an open circulatory system that doesn't include a pump, right? That's like your, which system, Jordan?
The lymphatic system, which is also open.
Question number 180. Arthropods, as a taxonomic unit, are considered successful because, well, let's see why they're successful. It says in the passage they have species diversity. That means a lot of different species, which would mean, one, there are numerous species, so one must be part of the answer choice. B is out. Number two, many individuals have relatively long lifespans. Let's see, it does say species longevity, but that's not what it's referring to in terms of an individual's lifespan. It's referring to how long a single species has been around. So in other words, a bacterium has a short lifespan, but if you have a species of bacteria that has been around for millions of years, even though the individuals live for a matter of hours, that's still a very successful species. So 2 is out. Number 3, flying species. There are aquatic, terrestrial, and flying species. If we take a look again at the passage, it says a variety of ecological niches. So answer choice 3 is in. That gives me choice C, 1 and 3 only. And that's direct from the passage.
181. After observing the well-defined nervous system of several insect species, a student concludes that all arthropods must have a true coelom. Is such a conclusion warranted? Now, the trick to this question, and I hope you didn't spend a whole lot of time on it, is you have to know what a coelom is. And unfortunately, this is difficult science to memorize. A coelom is a body cavity completely lined by mesodermal tissue. So let's find the answer choice that's going to agree with that. B says, no, coelom development and nerve tissue development are independent processes. You need to understand that nerves, a lot of nerves, can develop completely from ectodermal tissue. So B would be the best answer to this particular question.
That's good, Jordan.
Thanks, John. I thought I did a particularly good job on question number 181. Here it is. And it doesn't say that there's anything wrong with taking 14 of them. Oh, wait. Yes, it does.
Give me that.
I don't feel so good.
Have a seat, have a seat. I'll do passage 8. Okay. Question number 182. According to the passage, prostaglandins most likely, if we look in the passage, it says according to the passage, if we look in the passage at the last paragraph, it says aspirin is a potent anti-inflammatory because it blocks synthesis of prostaglandins. That must mean that prostaglandins create inflammation. So prostaglandins most likely enhance the effects of inflammation, choice D. 182 is answer D. 183. The reaction 3 involves all the following transformations except, if we take a look at reaction 3, which I happen to have right here, we see Ammonolysis. Ammonolysis is adding an amine to something and breaking it apart. And that's what we have here. Lysis is to break apart. So choice A is out. Remember, this is an accept question. If we take a look at choice B, hydrolysis of an acid. Do we have an acid? We have an acid. Is it being hydrolyzed? No, it stays intact. So choice B looks like it's the right answer. Let's just look at C, amide formation. No amide here, and over here we have an amide right there, the amine and the carbonyl. Take a look at choice D, phenol formation. Over here we have benzene, no phenol. Here we have the alcohol attached to the benzene, that's the phenol. So D is also there. It's an accept question. Best answer is B. Question 184. One competing side reaction in aspirin synthesis is an esterification reaction between the acid group of aspirin and the hydroxy group of salicylic acid. What is the product of the side reaction? If we take a look at reaction 1, we see salicylic acid. Here is the hydroxy group of salicylic acid, and here's the acid group of aspirin. Now, when an alcohol reacts with a carboxylic acid, you should know this reaction. The two lone pairs of electrons on the alcohol, on the oxygen here, are going to attack the carbonyl carbon. Remember, carbonyl carbons like to undergo nucleophilic addition or substitution. In the case of a carboxylic acid, Jordan, it would be nucleophilic substitution, right. So this oxygen attaches here, releasing this OH group. So what we end up with is this group here attached here. Well, we take
ester, right? An ester.
It is an ester, correct. So if we take a look then at our answer choices, we have A, our ester group, right there. (185). What is accomplished by the filtration that is performed after reaction 2? Well, if we take a look, it says after filtration, to remove insoluble contaminants and after workup of the filtrate, the most likely impurity in the final product is salicylic acid. So after filtration, the most likely impurity is salicylic acid. So choice C says solid polymer impurities are separated from the water-soluble sodium salts of salicylic acid and aspirin. Why is that the best answer, Jordan?
Because the question is essentially asking what is accomplished by filtration. And of course, in filtration, you want to remove impurities. And in this case, you would want to be left with the water-soluble sodium salts so that you could make the salicylic acid.
Good. Question 186. Which of the following cannot be partially responsible for the contamination of aspirin by salicylic acid? All right, so they're asking which cannot be, and notice that cannot again, you probably want to circle that, be partially responsible for contamination of aspirin by salicylic acid. Now, this question is not as difficult as it looks. If you take a look at choice D, aspirin can decarboxylate to form salicylic acid in the presence of sodium bicarbonate. If I take a look here, I look at aspirin, and here's aspirin. If aspirin decarboxylates, does it form salicylic acid?
It does not. You'd lose CO2 in decarboxylation.
Right. Decarboxylation takes the CO2 here. The carboxylic acid group is removed, and we would not end up with salicylic acid.
We're looking at the second freestanding set of questions, questions 187 through 191. Question 187 reads, if a person's gallbladder is removed, the person should restrict the consumption of, one thing that is must know for the MCAT is that your gallbladder produces bile, and the function of bile is to emulsify fats. In other words, if they take your gallbladder out, you got to have another way to digest or emulsify your fats so that you can digest them. Let's find the answer choice that says fats, proteins, no, polysaccharides are sugars, triglycerides, that means fat. C is the right answer. Lactose is obviously a sugar. Yeah. 188. Sorry, you want to do this one?
Okay. 188. The shark intestine is shorter and less convoluted than that of mammals. The shark intestine, however, is not hollow, but contains a spirally folded mucous membrane, the spiral valve. The spiral valve is most likely analogous in function to the mammalian. Now, if it's convoluted, and this is the intestine, what are they getting at? What in the intestine in the humans is also convoluted?
Something with increased surface area, certainly.
Exactly. That's the whole idea here, increased surface area, and that would be the intestinal villi and convolutions. Answer choice C.
Great. 189 says, what is the formula for the compound tert-butylamine? Well, I took the liberty of drawing up the T-butyl group here. We got the carbon in this T-butyl arrangement, and then what I'm going to do is throw in the amine, and now all I have to do is find the answer choice that corresponds to this structure. And that looks to me like answer choice B. We got the CH3, 3 of them, the internal C here, and then the NH2 bound to it. 189 is B.
Right. For 189, you have to recognize these condensed formulas, and if you're not sure how, you should take a look at the organic chemistry book. We will cover that. 190. Inbreeding can... Actually, Jordan, this is your topic. Why don't you do this one?
All right, I got it. 190. Inbreeding can reduce the fitness of a population in the short term because it causes an increase in the... Well, we all know that inbreeding is bad. Why would it be bad? I mean, why don't you want to fool around with your cousin? Because it gives you bad things. The incidence of bad things goes up. Best answer is D. Incidence of expression of deleterious recessive traits increases.
That and you get arrested. Okay, 191. The outer layers of human skin are composed of dead cells impregnated with keratin oil, which make the epidermis relatively impermeable to water. That's the key here, impermeable to water. Yet humans sweat freely in hot temperatures. This occurs because, and you need to know that sweat glands have special channels through the skin, and they're going through, there are channels in the skin, the water isn't coming through the skin. So answer choice B here.
So we're working on passage 9, practice test 5. Passage is all about adrenaline. Ready to get started, John?
Yeah, why don't you do this one?
Okay, I'll take this one.
What are you doing?
Well, it's all about adrenaline, so I'm just getting my adrenaline glands going.
You're such a joker. Why don't you just do the passage?
Okay. Anyway, adrenaline, might also be called epinephrine, comes from the adrenal medulla, and that's actually what I was trying to stimulate in the back. Very difficult to do. And so the passage is all about adrenaline, and the adrenaline is apparently located in the bloodstream. So here's adrenaline located in the blood and flowing around in the blood, and what happens is when adrenaline is located in the blood, it then interacts with the cells such that, so here's the blood and here's the cell interior, something happens such that glycogen in the cell, and glycogen is what, John? It's the large storage form of...
Yeah, so large carbohydrates.
Large carbohydrates. Storage form of glucose. Glycogen is broken down within the cell in the presence of adrenaline into glucose. And then what happens is somehow this glucose comes from within the cell to out of the cell, and we increase the glucose concentration in the blood outside the cell. Increase the glucose concentration in response to adrenaline. The whole passage then is about experimentation to see how and why that happens. Question 192 reads, what is the most likely explanation for the result of experiment 1A? Well, if we look in the passage, experiment 1A is adrenaline and glycogen are mixed with the various hepatocyte fractions, in other words, parts of the cell, and results are indicated below. 1A says we've got cytosol, in other words, we've got the fluid of the cell, we've got adrenaline, good, but we've got glycogen, but when we do the reaction, we get no glucose formed. In other words, something's missing. Well, what's missing? The thing that's missing is this thing right here, the thing that separates the cell from the blood or the cell membrane. So there must be something really important going on at the cell membrane that contributes to this process. What is it, and what's the answer? B says a secondary messenger could not be produced. You need to know that in the cell membrane, there are proteins interspersed throughout here that will facilitate this reaction. And one of the parts of this reaction, adrenaline is a protein-based hormone. So it's going to excite the cell to do something, but because it's a phospholipid bilayer here, the protein can't get across the cell membrane. It has to work via a second messenger. Might be cyclic AMP. In this case, it is cyclic AMP. And it needs to exert its effect that way. So 192, the best answer is B.
Now, Jordan, did you have to know that the membrane would be there? Because that seems like a lot of knowledge to have for the MCAT.
That's a good question, John, and I'm glad you asked it. Right. If you weren't totally sure that there was a membrane involved in this whole process, if you look at the evidence displayed for experiment 1C, it's got the same information as 1A does, but C says you've also got membranes. In other words, C is membrane, cytosol, adrenaline, and glycogen produce glucose. In other words, again, the membrane was the missing ingredient. Why was it? Because you need that second messenger, which must have the membrane. The second messenger is found initially bound to the membrane.
So that's what you had to know, is that the second messenger requires the membrane-bound protein.
Exactly.
And that's the, now, I get it, okay.
Good, so let's look at 193. Following its production in the liver, glucose may be partially oxidized to pyruvic acid or pyruvate in a cells. You got to know that glycolysis, the process of breaking glucose down into pyruvic acid, occurs in the cytoplasm.
So that's all this question says?
That's all it says.
The way they've worded this question looks like there's a lot more to it, but really the question is simply saying, where does glycolysis take place? So you just have to know that pyruvate is produced by glycolysis and that glycolysis takes place in the cytosol.
Exactly.
I got it.
And you know what's interesting about this is MCAT is a simple science test, but the way they present stuff sometimes doesn't seem simple, right? They could just ask you, this question could easily be written, where does glycolysis happen? And then you just say, well, cytoplasm.
That'd be too easy.
Yeah, it would be too easy.
I get it.
Next question, 194. The enzyme that catalyzes the production of cyclic AMP is adenylate cyclase. Studies have shown that adenylate cyclase is a protein complex of high molecular weight. Which of the following statements regarding this enzyme is correct? Now, there's a lot of words in this question. You get to the bottom of this question, and you're kind of like, I don't really understand the question. And I think the tendency for most of us is to go back and reread it. I mean, it's all these multisyllabic words. What you have to know about cyclic AMP is that it is a second messenger. In other words, going back to the diagram that we had used initially here, adrenaline found in the bloodstream must exert its effect on the inside of the cell somehow. How does it do it? It's going to bind externally and use that second messenger to create a chemical chain of reactions that are going to result in the production of glucose. Let's find the answer choice that says that. Answer choice C says adenylate cyclase activity is stimulated by adrenaline. What happens is adrenaline binds externally and the adenylate cyclase activity, in other words, the production of cyclic AMP begins.
So in that question, this complex of high molecular weight is a red herring. We didn't have to know anything about that.
Totally throws you off.
And the way we would realize that as we read it is the first thing you ask yourself, I ask myself when I read an MCAT question is, what is the simple science involved? What is it that I need to know? And I need to know what is cyclic AMP. If I can answer it with that information, I'm going to do that.
Move on. Yeah, where high molecular weight might be important is if they were putting it on a gel and trying to migrate it, for example, then high molecular weight might be important, but other than that, no. 195. In the schematic diagram below of a portion from a hepatocyte plasma membrane, which of the following substances or compounds is represented by structure X? Well, structure X is that thing that is outside the membrane, right? In the blood, outside the cell, and then we've got the part that's inside the cell over here, and then this intervening set of bars in your diagram there is the plasma membrane without the phospholipid stuff drawn in. So the thing that's outside and binding to the receptor must be adrenaline. Let's find the answer choice that agrees with that. Oh, A. Adrenaline is the thing outside the cell that binds, that causes the chemical cascade. Question 196. Which of the following hypotheses is not tested by experiment 1? John, you want to handle this one?
Sure. For this question, a question like this, you need to read the answer choices and just one by one ask yourself, is this one tested? It's really the only way to do it. So we'll just start with A. Adrenaline is a necessary component for the breakdown of glycogen. So if I'm going to test for that, I'm going to test it when adrenaline's there, and I'm going to test it when adrenaline's not. And then if adrenaline's not there and there's no breakdown, I'll know adrenaline is a necessary component. Let's take a look at experiment 1. That's what the question tells us to look at. In A, B, C, and D, adrenaline is there each time. So they never tested it for when adrenaline was not there. Therefore, A is the correct answer. They never tested whether or not adrenaline is a necessary component for the breakdown of glycogen.
Question 197. Which of the following reactant combinations should yield glucose? All right, so we've got a kind of a tough problem here, and the information that we're going to need to answer this question is in experiment 2, or in the passage where it says experiment 2.
Because that's where they talk about the boiled extract.
Exactly.
Got it.
So we're going to have to figure out at some point what the boiled extract contains, but if we look at the results of experiment 2, when we took in A, cyclic AMP, cytosol, and glycogen yield glucose. In other words, Roman numeral 3 yields glucose. So any answer choice that's correct has to include Roman numeral 3. A and B are out. Now let's figure out what's in the boiled extract. It says in the passage, the mixture was boiled and extracted, and a portion of the boiled extract was purified for assay. Two of the constituents found were cyclic AMP and 5' AMP. In other words, the cyclic AMP is within the boiled extract, meaning Roman numeral 1 must also be correct. The only one that works then is D.
And Roman numeral 1 is also correct because boiled extract is the cyclic AMP. It has the cyclic AMP in it. So 1 is the same, really, as 3.
Sure.
I got it.
198. Which of the following chemicals is a primary messenger? Well, we've already got it drawn in our diagram. Adrenaline binds to the outside of the cell, instituting a second messenger reaction. Adrenaline is our primary messenger. You got to know it.
That's why they call cyclic AMP a secondary messenger, because there is a primary messenger. I never thought about it that way. You've got the primary and then the secondary.
Great. And it's just taking the message that adrenaline brought. Ah! No, John!
I'm just trying to clean it up, man.
Achoo! Oh, you see, I told you. See that virus right there? I'm spitting them out all over the place.
You can't see viruses. They're too small. Viruses are much smaller than bacteria even.
Just do the passage.
All right. Passage 10, number 199. The confining membrane shown in Figure 1 is most similar structurally to and if we take a look at Figure 1, the membrane, that's a phospholipid bilayer. And where does that phospholipid bilayer come from?
It's got to be a eukaryotic cell.
Exactly, because the viruses don't make their own phospholipid bilayer. They borrow that from the host cell. The host cell is the cell that they're infecting. So we're looking for a eukaryotic cell membrane. Number 200. Which of the following conclusions regarding virion biology is supported by information given in the passage? When you get a question like this, before I go to the passage, I'm going to go through the answer choices and see which ones are true, because I know the correct answer must be true as well. So maybe I'll get rid of some of the answer choices before I have to go fishing in the passage. So is it true that virions lack genetic material? Well, what is a virion anyway?
It's a virus that's inactive.
Exactly. It's the virus outside its host cell. So it's the way we usually picture a virus, with the capsid and the tail fibers. So does a virion lack genetic material?
No, it would have it.
Yeah, of course. A virion has either RNA or DNA. Never both, though, right?
Right.
Virions can synthesize proteins. Is that true?
No.
No, they can't, because virions are inactive. Virions lack enzymes. Is that true? Take a look at Figure 1. There's a virion, and
Yes.
we have reverse transcriptase. So virions don't lack enzymes. So the answer must be D. Is D true? Virions are obligate parasites. Yeah, virions require a living host cell. Question 201. In regard to their relative size, the described objects are. Now, the described objects are the viruses. So, and viruses, you need to know, are much, much smaller than even bacteria. So, answer choice A, smaller than all known eukaryotic cells.
Now, you knew that just based on science knowledge, or you knew that because you had read in a passage that when they used a light microscope, they couldn't see it?
I knew that based on science knowledge. For the MCAT, you want to know that viruses are very small.
Okay.
Number 202. Which of the following media would most likely be used to grow virions in a laboratory? What are they getting at here?
They're getting at the same thing they got at in question 200. And in question 200, you need a host for the virion, or for a virus, you need a host. So in this one, you need a host.
Exactly. For a virus, you need a living cell. The virus cannot reproduce itself without a living cell. In 202, there's only one answer choice there that is living cell, and that is a tissue culture. So the tissue means living cells.
A nutrient broth soup sounds pretty good, though, I'll tell you.
Okay. 203. Most viral proteins are produced directly by, and this question is really just asking about how do we make proteins? Is it translation or transcription?
We make proteins by translation.
Right, because transcription is going from...
Making nucleic acid.
Exactly. In transcription, we're going from DNA to RNA. Translation, we're going from RNA to protein.
So C and D can't be right.
C and D are gone.
Got it.
So we have A and B, translation of host nucleic acid or translation of viral nucleic acid. We're trying to make viral proteins. The proteins, that's the DNA or the RNA within the virus. It injects that in there, and that's what it wants to translate into proteins. So it is translation of viral nucleic acid. Choice B. 204. A microbe pathogen was hypothesized as the causative agent of the disease described in the passage because, is it one, suspicious objects were found in blood samples from ill patients?
They're UFOs, unidentified floating objects.
What's wrong with one, though? One is that do they find the virus? Is that how we diagnose a viral infection?
No, you can't see them.
Yeah, they're too small. We don't see them under the light microscope. We're not looking for the virus itself, so one is out. How about
C and D are out.
Well, C and D are out, right, because that's exactly Roman numeral 1. Thank you, Jordan.
You got it.
Okay. Number 2, in vitro cultivation of probable pathogens was difficult. What's in vitro?
You know, I have a really hard time remembering sometimes, and what's interesting to me about that particular answer choice is, if I get confused or if I don't know what in vitro is, I can look at Roman numeral 3 and I can say the disease was infectious. That happens to be a truism because that's how you'd know the virus is going from person to person. That would indicate to me that B was the right answer, and I wouldn't even have to wonder about B, about A.
Good point. So here we didn't even have to know what in vitro was. In vitro means it is created in the lab. It's done in the lab. So in vitro cultivation of probable pathogen was difficult is out because the disease is infectious. Of course, we know number 3 has to be in, so answer choice is B. Okay, we're on passage 11 now. Jordan, is it okay if I do passage 11?
Oh, by all means, go ahead.
Great. This is an excellent passage. It shows that MCAT's really getting into organic chemistry and starting to test more and more organic chemistry. They're talking about in the early 1900s, these two guys, Diels and Alders, working with conjugated dienes. So there's a lot of complicated chemistry here, and what I'd like you to do is get your organic chemistry textbook out.
What?
And yeah, we're going to do
John,
it.
what, are you doing passage 11 here?
Passage 11, yeah. There's
Have you looked at the
complicated. I haven't yet. I was reading the passage.
Better start looking at the questions, buddy.
Are you gonna do
maybe
this?
I better do this passage,
Okay.
okay? It seems on the surface that passage 11 is about difficult science, and it's interesting to me that they use 2 full columns of text here to describe Diels and Alders' important work. But on the MCAT, it's much simpler than that. On the MCAT, we've got to read through the nonsense, and we've got to see the science underneath. So let's turn immediately to the questions then, without any further ado, and look at question 205. It says, according to the diionic mechanism proposed by chemist 2, which of the following structures represents the reactive intermediate of the reaction described by entry 2 in table 1? So let's look at entry 2 of table 1, and entry 2, table 1, here is what I've got up on the board. And we've got our diene and our dienophile. And we're going to form this product right here. So we're looking for the intermediate, or the thing that we're going to form in between there somehow. And if we look then at our answer choices, which I guess we'll just put up over top here, we've got our 4 answer choices. And obviously we want to try and eliminate any answer choices that we can immediately. And I'm looking at this one right here. We've got a positive charge on a doubly bound carbon. That's not going to happen. And then over here, we've got a positive charge outside and a positive charge outside. It's not likely that we're going to lose the proton there in the intermediate.
Wait,
over here.
Basically, A and B are the same answer.
You know, you got a good point. Yeah, they're just flipped. Good. So A and B are out. So we've got C, the only answer choice that makes sense. Looks like the final product here could be an intermediate in this reaction, and we've got the positive or the carbocation on the right carbon.
So you're right. There was no orgo here. A and B are the same answer. You should recognize that, right? They literally are the same molecule. And between C and D, D has a positive charge on a carbon with 4 bonds.
Doesn't going to happen.
Wow.
Yeah.
All right.
C is right for question 205.
Yeah, but certainly these other questions are going to get tougher.
Yeah, probably.
They're going to need their textbook.
Let's look. 206 says in the reaction described by entry 4 of table 1. Again, table 1, entry 4. A 1-to-1 mixture of 2 products was observed, and the second product was identified as the enantiomer of the product shown in the table. What is the structure of the second product?
Now here it's important to know that about the 1-to-1 mixture as opposed to a 2-to-1 mixture.
It would certainly seem that way, right? But the truth is, this question is really asking, what is the enantiomeric brother of the product here? And the thing about that is, you need to know obviously about enantiomers. They are non-superimposable mirror images. We got that information down. And if they give you a complex structure like they have here in entry 4, what you have to do, the enantiomeric brother, you've got to flip every one of the stereochemically active or the chiral center in this molecule has to be flipped. In other words, this uppermost carbon in the ring and the lowermost carbon in the ring each have hydrogens, or I'm sorry, those would be carbon groups sticking out towards us, and then this carbonyl group is pointing off, this carbonyl group is pointing off towards the back of the ring. We've got to flip all three of those in the correct answer choice. Obviously then, we looked at our answer choices. A is out because the uppermost carbon pointing in the wrong direction. It has to be flipped in this case. B looks like a good answer because these two here are flipped, and this one is also flipped. Let's leave B alone for a second. C is out because these two are right, but this one is wrong. And D is out because these two are not flipped. So D is out, C is out, A is out, leaves B. We already agreed that B is the best answer.
So all this extra stuff, the one-to-one mixture, the reaction from Table 4, all of that is just a red herring. They just needed to look at Table 4, see that molecule, and find its enantiomer, which is just the mirror image.
Amazing, isn't it?
No organic chemistry, or very little. Again.
You know what happens is students get so intimidated by organic chemistry anyway, then you see it on the MCAT, they put these 2 long columns, they're talking about Diels and Alder, and you're thinking, I struggled with that in organic class, and then when you look at the science, it's just general, simple science.
So the way we avoid this is when we read the question, we think about what can the MCAT really ask me here? What are they really testing? And look for that simple science first before going to the more complicated stuff.
Exactly.
I got it. But 207, we're going to need the textbook.
Yeah, let's try. Okay, question 207. Which of the following structures is a resonance structure of the intermediate shown in Figure 3? So in this one, we actually do have to refer back to the passage. We'll look at Figure 3, and we've got this intermediate drawn in Figure 3.
Now, when we draw a resonance structure, the things we can move again are what?
We can move electrons, but we can't move atoms.
I see. And if it's got a molecule has if one of the resonance structures is neutral, like this one is, all the resonance structures have to be neutral.
Good point. So let's see if we can eliminate any of these answer choices based on simply that fact. And B jumps out at me immediately. B has to be wrong because we've added a positive charge. That can't be the right answer. So now we're going to look at A, C, and D and look preferentially, find the best answer. On D here, looks like we've got a positive charge on a carbon with 4 bonds already. D is out because that structure is just not going to appear.
It looks like it has 3 bonds to me.
This one? Well,
yeah.
We're not drawing the hydrogen.
Oh, the hydrogen, right. Okay.
Yeah, okay. And what else do we got? So we're down to A and C, and we got to find the right answer. And we're looking at a resonance form of this intermediate. So the answer, we got the negative charge here in the crux, and we've got our double bond here.
Oh, and also look at A. A also has the same thing. That negative charge is on a carbon with 3 hydrogens.
That's a good point.
4 bonds there. So A can't be right either. So C, the electrons are just jumping from one place to the other.
And the trap here was in answer choice C just moves the position of the double bond. That's allowable.
Because the second bond is a pi bond. So it's just 2 electrons that can jump back and forth.
Good to know. 207, best answer, C.
So that question was just, what's the resonance structure to this structure, right? To the structure in Figure 3. All right, again, very little organic chemistry.
That's all it was. 208 then. According to the observations made by the 2 chemists, why does the following reaction not work? Okay, so we're looking at these 2 reactants. And it looks to me, John, like we've got a diene and we've got a dienophile. But we've got a reaction that is not going to work.
And the diene is the one with 2 alkene groups.
Right.
Right. 2 double bonds. Diene.
Dienophile. So there's, for some reason, this particular reaction is not working. So let's find out why. And in this question, we actually do have to read in the passage a little bit. In the second paragraph, it says that Diels and Alder discovered that the reaction was more favorable when dienophiles with electron withdrawing groups. In other words, the dienophile, the thing that is going to love the diene, must have an electron withdrawing group. And so if we look at this particular group over here, we've got an OCH3, and we've got to wonder, okay, is that electron withdrawing or electron donating? And this whole question here is going to depend on that. And the thing we have to understand is that the O and the C, if we look at this bond, the oxygen has a higher electronegativity than does the carbon. In other words, when you're wondering about a substituency, you have to determine the relative electronegativities and the direction that electrons will flow. In this case, more electronegative, less electronegative, electron density will flow this way, making this substituency electron donating. This is electron donating. Diels and Alder found that electron withdrawing groups on dienophiles are best, That's probably why this reaction is not working. Let's find the answer choice that says that. A says the methoxy group, this being a methoxy group, is not electron withdrawing. In fact, it's electron donating. It's not electron withdrawing. That's probably the right answer. We look at the other answer choices real quick. There's no Lewis acid present. They said something about Lewis acid in under figure 2. It says because the rates of Diels-Alder reactions were enhanced by the addition of a Lewis acid. It doesn't say the reaction is going to happen or not, but the rate is enhanced. So if you got caught by that, understand that you got caught by language. C and D to me really are easy to eliminate. I mean, we already got the right answer is A. You should be able to eliminate C and D, and the choice then becomes a choice of A and B. Best answer for this question, A. Okay, so we're looking at the final set of freestanding questions in Test 5. Yay! And question 209 starts with, a researcher has a short polynucleotide strand with the following base sequence. It goes A, U, C, C, blah, blah, blah. As soon as I see that U in there, I know that this cannot be what, John?
It can't be DNA because
Can't be
uracil is only RNA.
Only an RNA, so we're going to eliminate a couple of answer choices. A and B are out. It can't be DNA. It has U in it. And then answer choice D says a peptide, which of course is
It's a protein.
a protein.
So we're talking
Can't be
C.
D. C is the best answer. Moving on.
Let me take 210. Number 210, which of the following statements about DNA methylation is most accurate? Now here, I'm thinking DNA methylation. I read the first answer. Thymine is the most highly methylated nitrogenous base in DNA. I don't know the structure of each purine and pyrimidine, but I know that there's some methyl group on some of them, or at least one of them. So A is a possibility. B, highly methylated DNA is typically less actively transcribed than unmethylated DNA. Again, I know there's some methyl group on some of these, so I know B is not a true statement. What's unmethylated DNA? I've lost my nitrogenous base. Or I've changed it. C, the methylation pattern of daughter strands is unrelated to the methylation pattern of template strands. This is silly. The methyl group is on the nitrogenous base, and one strand is complementary to the other, so they are related. So C is an incorrect answer. D, inactivated X chromosomes in female mammalian cells are typically less methylated than other chromosomes. Now, I know inactive X chromosomes, we're talking about bar bodies, and there's nothing related to methylation for bar bodies. So D is wrong as well. So here I can get rid of B, C, and D, and then I'm comfortable answering A.
Am I up? Oh, 211. Compound X is shown below. It's also drawn up on the board. And what we have in compound X is we've got this is compound X, and we got to figure out which of these answer choice compound X corresponds to. So when I'm looking at compound X. We've got an ammonia group and a carbonyl group. This would be my acid group and my amine group. In this particular amino acid, I've got a second amino acid here with an ammonia group and an acid group, and here the nitrogen would be part of this third amino acid group, so we've got 3 amino acid residues in my peptide here. Let's find the answer choice that agrees with that. It wouldn't be A or B, obviously, because those would be dipeptides. So we got a tripeptide. It has to, if it's a tripeptide, it has to contain 2 peptide bonds. Best answer then is C.
Wait, so you're saying a tripeptide contains 2 peptide bonds?
Kind of bizarre, isn't it? But a
Yeah.
peptide bond is
So
going to
the
be a bond that's going to connect one amino acid to another amino acid. And if you have 3 of them in a row, unless they're linked this way, which doesn't happen.
So the di and the tri relate to or correspond to the amino acids.
Tripeptide relates to the number of amino acids. Let's look at 212. 212 says DNA polymerase catalyzes the replication of chromosomal DNA in bacteria as shown below. Blah, blah, blah. A double-stranded DNA molecule contains bases with a ratio of A to T to G to C of 3:1. This molecule is replicated with DNA polymerase in the presence of 4-deoxynucleoside triphosphates with a molar ratio of A to T to G to C of 1:1. What is the expected ratio of A to T over G to C in the double-stranded daughter DNA molecule?
That's an unbelievable question.
I know, I'm going to have to look at the bio book for this one.
No. Look, this is really easy, actually. Just the way they worded it. What they're asking is, does the ratio of nucleic acids change when we go through replication? And the answer is no. There's no change, right? When replication, we get the exact same two strands. So if it started at 3:1, it ends at 3:1.
So you're saying that if the mother strand has a 3:1 ratio, and you undergo replication, then the daughter strand is also going to have a 3:1 ratio.
Right. And that's all the question is asking is, when replication occurs, does the ratio of one amino acid to the other change? And of course not, because replication produces the exact same DNA molecule.
Don't overlook the fact that they used all that text to ask that question. I'll go back to something I said earlier. There's a simpler way to ask this question. You could just say, hey, if the mother strand has this certain ratio, the daughter strand after replication should have the same ratio. And that'd be a much simpler way to sort of phrase the question. But they put all this information in there because they know it's simple science, and they got to have some way to separate the people who see the simple science through it from the people who are intimidated by it.
Now, number 213. Number 213 is, again, we had this question before. They're really requiring us to know the condensed formula. And you look at this formula and you have to recognize that there is a ketone group there. That's that single oxygen there with the parentheses on it, and that is attached to the carbon. On either end here we have benzene groups. And you're just going to have to recognize this, that there's a ketone group there. Answer choice D.
Good. And last question, 214. Assuming that the breathing rate is 10 times per minute. So we're going to breathe at 10 times per minute. And the tidal volume is 800 milliliters per breath. And the non-alveolar respiratory system volume, in other words, dead space, is 150 milliliters. What is the net volume of fresh air that enters the alveoli each minute? So the tidal volume, if you think about what those words mean, if you don't know what it means in advance, tidal volume is the entire tide that enters the entire respiratory system. That's 800 milliliters for each breath. You're going to do it 10 times. In other words, that total will be 8,000. But each one of those breaths contains 150 milliliters of what they call anatomic dead space. In other words, the trachea itself, the bronchi, right? Those are not alveoli. Those are dead space. So we have to subtract from this 8,000, this 10 times 150, or 1,500 milliliters, making the total volume that passes by your alveoli each minute. If you're breathing 10 times a minute and you have this kind of respiratory volume, 6,500. Best answer, C.
You know, what's interesting about that question is, even if I didn't really understand this, that 150 milliliter, I know I've got to pull that out. I've got to subtract it. And I could have got answer choice D. I could have said 8,000 minus the dead space only counts once. But if it only counts once, think about what that means. That means the moment you're born, you take a breath, and that 150 milliliters, that is a dead space, and that only counts once. And for the next 10 billion breaths you take, it never counts again. That's kind of silly. Doesn't make any sense. And so, you know, for 20 breaths, and it's